coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz. Coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz. Coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz.
Hello? Okay, now it works. Hey, so welcome to the second day of Rejekts. Welcome to the second day of Rejekts. I hope last night wasn't too complicated for people. So, Yeah, let's get started. So our first speaker is Madhuri here, and she'll be talking about how a lab computer builds distributed notebook as a service. Yeah, that's confusing. Yeah, so using Federated Kubernetes, how a notebook as a service was built. So yeah, thank you.
Thanks so much. Good morning, everybody. Thanks for waking up early in the morning, and hope you all had your coffees by now. This talk was originally supposed to have been presented by Pankaj and Chi. Neither of them could be here because of passport restrictions and visa restrictions and COVID and all that stuff. So the content and the talk was put together by Pankaj and Chi. I am sharing the content that they put together, so I want to acknowledge that. Pankaj is the founder of Lab Computer, and Chi is engineering manager at Elotal, and I'm Chi's coworker. So in this talk, we'll go over what Lab Computer is, what they're trying to build, and why they chose Kubernetes as the basic building block for what they're building, and why they needed to federate Kubernetes and have Kubernetes clusters in multiple geographic locations, and what are the tooling that they use to manage and orchestrate across multiple Kubernetes clusters, and the lessons learned and best practices that Lab Computer and Pankaj would like to share with the community. Lab Computer is an online IDE platform which is built as a SaaS product. It's a single portal for building educational content for students and instructors. They want to build an online platform so that it's easy for students and teachers to work on assignments and learn AI and machine learning concepts as the first domain that they want to tackle. And they want to expand beyond AI and ML and include other STEM subject matter concepts as well. So Lab Computer website is a SaaS portal. You log into a SaaS portal as an instructor, and you create notebooks that have AI and machine learning workloads. And students can log on to the portal, and they can learn AI and machine learning concepts using these pre-built notebooks. And they can also submit their assignments and get graded. They want to automate the grading process as well. So most of the graded assignments are automated, and it's easy for both students to access content and for teachers to automatically grade and bring about new coursework assignments to students. So while building this notebook as a service, Pankaj and the team at Lab Computer had certain design goals. The first design goal is the user experience for the students. As a student, they want the students to have the same user experience as if they had the coursework assignments on their local laptops, which means that they want to be able to spin up the assignment really quickly, run these machine learning workloads really quickly, and also checkpoint the state and be able to resume the assignments and homework 2 days later or a couple of months later. And from the instructor and teacher point of view, they want the teachers to be able to create content super easily, and they want the teachers to expand beyond a set of machine learning workloads. They want to expand to other STEM subjects as well. And they also want grading to be super easy and automated as possible. And from the Lab Computer operations team point of view, they want the Lab Computer team to be able to host untrusted workloads, assignments that are submitted by students, and they want to be able to run it inside their cloud accounts without worrying about any kind of security issues. So when they were looking at the basic building block for their infrastructure, Lab Computer ended up choosing Kubernetes because we are all here for KubeCon and Rejekts, so we don't need to be sold on Kubernetes, but it's nice to see someone that's trying to build a real-world end-user product making a really conscious, logical decision about picking Kubernetes. So the reason they went with Kubernetes is because it's easy to switch between cloud providers, and it is is secure, and there's a lot of community ecosystem in place for logging, monitoring, and also when they want to build an enterprise version of this product, they would need to add in hooks for cost management, stuff like that, and billing, and the ecosystem has hooks in place already, so it was an easy decision for them to build, to pick Kubernetes as the basic building block. Once they decided on Kubernetes as the basic building blocks, the next question they had to answer was, how do we make sure that a student that is residing in US West 1 it has the same kind of user experience as a student residing in Singapore or in Mumbai, India? Lab Computer is a startup that was born, that was created in San Francisco. So they started with US West 1 GKE cluster as their basic building block. But then they realized that sometimes the student would log in from Singapore, and the student would take 15 minutes for their notebook to pop up, and that kind of latency was unacceptable. They also received complaints from other students, say in Eastern Europe, saying that sometimes there weren't network routes from Eastern Europe to US West 1, so not having the right network routing available, plumbing available, was another reason for thinking about creating multiple clusters in multiple geographic locations. And the third reason is cost. Lab Computer, being a small startup, they were very cost conscious, and they didn't care where the compute was located as long as they were able to consume the low-cost compute needed for their user notebooks, as long as it satisfied the user notebooks resource requirements, as in I need X amount of CPU, Y amount of memory, and this kind of GPU device. So as long as they were able to procure the right compute at the right price point, they wanted to be able to ship the workloads to the right availability zone that had the lowest cost compute. So once they decided to create multiple Kubernetes clusters, they first started with expanding beyond US West 1 into an availability zone in India. So they created their second GKE cluster in Mumbai. And once they had the second GKE cluster in Mumbai, they were thinking about, hey, how do we scale this beyond 2 Kubernetes clusters, and how do we scale this to accommodate all the student workload requirements as we scale the company and as we scale our workloads? They didn't want to treat each Kubernetes cluster as a pet and hand manage each of these Kubernetes clusters. Their operational team is small, and they didn't want to spend their time taking care of these Kubernetes clusters and nurturing these Kubernetes clusters as pets. They wanted to focus on building the Lab Computer platform and adding on more coursework notebooks to their platform. So that's where Nova comes in. Nova is a policy-driven scheduler that schedules your pods across multiple Kubernetes clusters. So as a user, you supply your pod manifest, and you either annotate it or you specify a policy saying, hey, these are my requirements for my pod, for the pod's compute. So you can say, I want a low-cost pod policy, or you can say, you can specify applications SLA requirements, as in my notebook needs to start up within 5 seconds. And what Nova does is it schedules the pod to the right cluster in the right availability zone, in the right region, in the right cloud provider that honors the application's SLAs and that honors the user-defined policies as well. So Lab Computer decided to manage the federated Kubernetes clusters using Nova. So the way Nova is architected is you have a single control plane which speaks Kubernetes API server, and all kubectl and other client requests hit the API server for the Nova control plane, and you have workload clusters. So what Nova does is it enables you and empowers you to treat workload clusters as cattle as opposed to pets. So if you think about the idea of commoditizing compute for a single Kubernetes cluster, Nova takes this concept one level beyond, and it commoditizes workload clusters for a federation of Kubernetes clusters. So each of the workload clusters has a Nova agent. So from the end user point of view, the workload clusters are commodity as long as the workload cluster is honoring the user-defined policies and the SLAs for your application. It doesn't matter which workload cluster your user app is scheduled to. So when you look at how the federation of Kubernetes clusters is managed by Nova and is exposed to user, if you think about it from a student point of view, let's say a student is creating a new lab computer account, and he is located in Mumbai, India. So his request for creating the lab computer account hits the controller for lab computer. Lab computer converts that request into a pod manifest format with the right user-defined policies, and the pod manifest is sent over to Nova. Nova will schedule the pod to the GKE cluster that's running inside that's running in Mumbai region, and the user's pod is scheduled over to that GKE cluster. So you get the regionality that you want the user to experience, and from the user point of view, it's their latency problems are solved, their lack of network routing issues is solved, and the cost issues from lab computer are also solved, because lab computer added the user-defined policy of, hey, ship this pod to the low-cost compute in that region. So here is a demo of how lab computer staging environment is configured to work with Nova. This has been narrated by Pankaj, so I want you guys to hear it in his voice. So I'm going to play the recorded demo.
Hi everyone. In this video, we are going to show how lab computer utilizes a Nova control plane to distribute notebooks across multiple Kubernetes clusters in different geographies. We will also show how users in different geographies launch notebooks in the Kubernetes cluster closest to them. So here we have a Nova control plane with 3 clusters attached, out of which we are going to use 2 to power our staging environment. Let's look at the first cluster. The first cluster is running in India. You can see that with the geography, which is Asia South 1. The second cluster is running in the US. You can see that by US West 1. Now you can see that this is an RDP session that is running in India, Mumbai, and we'll launch the notebook here. This is my local machine running in California, and we'll launch the second notebook from here. We'll wait for the launches to finish. Now the India browser will go to a notebook running in India. You can see that from the ingress prefix India. You can also see that from the pods running in the India cluster. So you will see that a new pod came up 36 seconds ago. Now let's see the US website. This is running in the US. You can see that by the pods running in the US. You will see that a notebook came up in the US as well. So this way we can let our users connect to their nearest clusters and get the best experience. We are also going to make our sharding Nova aware so that this can be distributed across multiple of our courses, so that different courses can be in different geographies without the user even realizing it.
All right, I hope that demo was audible.
Hi everyone. In this video, we are going to show
So some of the lessons learned from Lab Computer's platform team by using Kubernetes as the basic building block and using multiple Kubernetes clusters across multiple geographic locations and trying to federate it using a single Nova control plane. The easy wins for them were that Kubernetes provided them with enabled them to go to market pretty quickly. And federating using Nova control plane also eliminated the operational complexity for their operations team so that they didn't have to treat each individual Kubernetes cluster as a pet that has to be hand managed. And it also reduced their operational cost of their cloud bills because Nova would automatically ship to the right cluster that had the lowest compute that satisfied the resource requirements for each pod. Some of the things that they wish to share with the community about federating is the notebooks especially have state associated with them. So if the student wants to pause their assignment and pick it back up 2 months later, that worked fine when they were restricted to a single Kubernetes cluster in US West 1 on GKE. They used clusterfs for sharding across multiple nodes, so any node in that single Kubernetes cluster could access the checkpointed state. But when you take this checkpointed state across multiple Kubernetes clusters that are geographically dispersed, they have to think about how to shard their clusterfs cluster across multiple Kubernetes clusters. So it is time consuming. So if you are planning to federate across multiple Kubernetes clusters, creating a plan for how do you handle state if you have stateful workloads, that would save you a lot of time ahead of time instead of arriving at the problem after you have created a federated Kubernetes environment. So that's all the content we have to share with the community. Thanks so much to the organizers like C, Benazir, Chris, everyone else. And thank you for attending the talk at 9:45 in the morning. Would love to hear your questions or comments. Yeah. So it's not yet open. So the question is Nova open sourced? It hasn't been made public yet, but there is a plan to have a free tier and a paid tier kind of thing. So open source strategy is still TBD.
Thank you so much for that. Thank you so much for that presentation. Where do you think in the CNCF Nova would fit in terms of like that entire map? Because there's so many different areas, and I'm trying to figure out like where it would best capture like particular areas in that landscape.
Yeah, so that's a good question. So where it fits is when folks have a need for managing multiple clusters at scale. For larger companies, if it's a large platform team, you have hundreds of clusters across 3 on-prem data centers and a couple of AWS regions and a couple of GCP regions. Instead of hand managing these clusters manually, that's where Nova fits in. It also fits in the ecosystem for smaller companies that don't have the bandwidth for hand managing clusters as well. If you're asking about the products, comparable products in the ecosystem, KubeFed, Karmada, these are the comparable products. So what Nova is trying to see is the problem is an emerging problem as Kubernetes adoption increases, and the number of clusters keep increasing with every month.
Thank you. Do you think Nova could be a platform to enable like other services for things like networking, storage, and any sort of extended capabilities that are required for certain applications?
Yeah, for sure. That's the question that we get asked quite often as to, for example, Pankaj at Lab Computer is like, does Nova solve federating storage for us or federating networking for us? So typically when you are thinking about this large-scale number of clusters across various geographical regions, you solve for compute first, and then you solve for storage and networking as follow-ons. So we would love to enhance NOVA to become a platform where networking vendors and storage vendors and projects in CNCF ecosystem can plug into it for sure. We are focusing on solving for compute and building the platform first. So think about it as the ecosystem is at a space where Docker was in 2015, where you're solving for one thing, and you could Docker plugin ecosystem had Flocker and Calico and others plugging into that to solve for networking and storage. So NOVA is not trying to solve all of these things. We would love for the ecosystem to solve for multi-cluster, multi-cloud storage and networking. We'd love to do that. Does that answer your question? Yeah. Mm-hmm.
Any more questions? Yeah.
Hi. Sorry, didn't catch it. When I'm submitting a workload to Nova, am I submitting just a regular pod template with some scheduler directive or something?
Yeah, let me... So Nova is simply a Kubernetes API server. So any Kubernetes client you submit requests just like kubectl, create pod, things like that. You also create policies on the side. So you can say that all pods that are red color, they need to go on clusters that have these attributes. So you create policies as CRDs on the side. So you don't change your manifest at all. You don't change your pod manifest or anything. Instead of your Kubernetes clients pointing to individual clusters as pets, you point to a single API server, that's the Nova controller, and you insert policies in a different channel so that Nova controller will ingest the pod request, pod creation request, or deployment, or any other object creation request, and it sees which policies apply to it, and it'll schedule to the right cluster based on the policies. Does that answer your question? Yeah.
Yes, thank you. Maybe you can think of OPA as a policy controller.
Yes, exactly.
For that, right?
Yeah. For sure, yeah.
Thank you.
Any more questions? All right. Yeah, thank you very much, Madhuri.
Yeah. Thanks so much for listening.
The next talk is in some minutes. Yeah, 10 minutes or so.
See the plague I have but you in yourself when no one's to be found. What keeps you eased out? What takes you off your mind? You better, yes, you want this, I want this. Everybody in this, you should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Yeah, you better take the time to recognize it. You won't leave me even if I tried it. You're the artist in the mass and happily perform the new in your hands. I sure gotta live right, and I'm never gonna let you out of my sight. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. All of the creation, the relations I got, the only one that keeps me safe, the only one you should trust. Yeah, you better. For sure, it ain't right that I have checked the speck of dust from all of this side. Hold down, not from my height, cause I didn't see the plague I have in my mind. You in yourself when no one's to be found. What keeps you eased out? What takes you should have it. Stop illusions, it's in your hands. Try yourself, reveal the data. Yeah, you better take the time to recognize it. You believe me, even if you tried it. You're the artist, I'm the mess, and happily you found the new in your hands.
yeah, the talk is going to be about bringing observability to developers, but for databases. So yeah, go ahead.
All right, thank you. So thank you all for being here. I'm Jan Kleinert. I'm a developer advocate at Google. This is what I looked like before the pandemic. I haven't gotten a new professional headshot in several years. And what we're going to be talking about today is database observability and what that means, why we care about it, and then SQL Commenter, which is an open source library that helps you accomplish that. So part of the reason that I submitted this talk was that I think SQL Commenter is really useful and I want people to know about it. The other reason is I'd like to hear from you if you agree that it's useful, if you see use cases you think it could help you with. I really would love to validate that with people, especially people who are with me in real life. So I'm around after the talk or on Twitter if you want to talk about it later. Okay, so we're going to start by talking about database observability in general, what it is, kind of what the landscape looks like, what the problem is that would require us to need this in the first place. Then I'll talk about SQL Commenter. We'll do a live demo, hopefully, and then there should be plenty of time at the end to share some resources, have Q&A, and for those of you who are here in this room, I'm going to ask for a quick favor if you're willing at the very end. All right, so particularly these days with lots of, complex distributed applications that are, built using microservices, it can be hard, if you're not a database expert, to troubleshoot application issues when they are likely related to databases. It can be hard to figure out where the queries are coming from and how to actually correlate that with the problems that you're seeing from the databases. Typically, not always, but typically developers don't have the same level of database knowledge and troubleshooting skills and stuff as like a DBA or someone who focuses on that as their full-time job. And more and more, especially with full stack developers, you're expected to know a little bit about a lot. And in this particular case, that can be really challenging. ORMs are one way to help make life easier sometimes when you're developing applications that use a database. They have pros and cons, right? They're not perfect, but they can certainly make life easier by generating those SQL statements for you, and you just have to write the code, right? But then if you think about troubleshooting with applications where the SQL queries are being generated by the ORM, you probably have even less knowledge about where a particular query originated from because you weren't even the one who wrote it, right? So that can also add complexity into troubleshooting database issues when you're using applications written using ORMs. So what do we do about this? How many of you are familiar at least a little bit with OpenTelemetry? So some of you. So if you are, then you're aware that it's a set of APIs and tools and SDKs that allow you to create and gather and monitor telemetry data, so metrics, traces, logs, things like that, and then use those to troubleshoot or gather data about your applications. So there hasn't really been a standard way of doing this for databases as well. There are some things out there that help you with database observability, but kind of what spawned SQL Commenter was the idea of well, what if there was a standard format, kind of like OpenTelemetry or part of OpenTelemetry. There's a typo on this slide that would allow you to propagate, not progate, application tags and traces to databases. So that is kind of where the idea for this came from. And that's what SQL Commenter is trying to do. So it extends the vision of OpenTelemetry to databases. So the way that it works is, and I'll talk through this in more detail in a minute, it can send trace context and other information to the database as SQL comments. And as you can see here, you can send more information than just that. You can send information about action controller, route, database driver, version, all this information along in SQL comments. In September of last year, SQL Commenter was donated to OpenTelemetry. So the donation has happened. What is still in progress right now is figuring out exactly how that'll be incorporated. So I think there's discussions going on still around that, but the project is out there. You can use it today. And we're hoping, the idea behind donating it to OpenTelemetry is just to make it not tied to a particular vendor, just make it out there so that anyone can use it or expand upon it and all of that. All right, so there's a link here to where you can find the repo on GitHub. There is also like I don't think it's mirrored. They're in the process of moving it over to OpenTelemetry, but this is, I think, the best place to find it for now. And this is what it is. Basically, it's an open source library that allows ORMs, or not ORMs, which I'll talk about too, to augment SQL statements before they're executed with comments that have information about the code. So it's really to help you tie application code to what's happening with those queries. And so here's where it's supported today. The languages that are supported are Python, Java, Node.js, and Ruby. When I was looking at the repo the other day, I saw there's something in there for PHP. I haven't tried it yet, but it looks like maybe there's now also PHP support, I think, for Laravel. For frameworks, there's Django, Connects, I'm not gonna read the whole list to you. There's a whole set of frameworks that are supported today. And what that means really is that if you use SQL Commenter with one of these, that auto tagging is enabled. So you can just add a little bit of code into your application, and if you're using one of these, then SQL Commenter will work for you out of the box. And the databases that are supported are Postgres, MySQL, MariaDB, SQLite, and Cloud SQL, Cloud SQL for Postgres and MySQL. And we're hoping this list is going to expand. We'd love to have people, contribute support for additional languages and frameworks and all of that over time, because this is kind of just the beginning. Okay, so let's look at how this actually works. I like having this here, I can point. So here we have a SQL statement, select from students. That's a really simple SQL statement. Select star from students. And then you've got this SQL comment here, and it's using standard SQL comment notation. You can find the spec for SQL Commenter here, and I mentioned before, you can have it work with ORMs to auto-generate these comments. If you're not using an ORM or you just want to do it yourself for some reason, you can also follow the spec here and just build these comments yourself and insert them in there. So the way that the format works is you've got your SQL statement and then the comment, which is a set of key value pairs. So they have to be comma separated, like you see here, URL encoded, and then sorted in lexicographical order. So all of that is in the spec, so you can see, and there's some pseudocode for how to do each of the steps and put it all together, and then how to actually parse it back out if you need to do that. But that's the example we have here. So we have action, controller, framework, and then the trace parent and trace state is that OpenTelemetry trace data. So that's really kind of all there is to it. By itself, it is literally just putting comments into SQL statements. But it's what you can do with it that gets interesting. And I should talk about that a little bit. So what can you do with this? So if you have these going into logs, like your database logs, for example, you can then, just look at the logs if you want, or you could import that into your favorite APM tools. Maybe you're pulling in logs from other sources and you want to add this too. I'll show you in a little bit how you can kind of see this stuff in CloudTrace. There's lots of things that you could do with this, depending on what you're trying to accomplish. But if nothing else, you can get it in your database logs and look at it from there. And here's a bit more of an example. So this is an example from an application that was kind of like a ride-sharing application. And so you can see in this log entry here, you've got your regular log stuff. You've got the statement that was made, and then we have the comment, which starts here. And you've got the controller, the database driver, framework, route, and then the trace parent. And I was gonna say obviously, but I don't know if it's obvious, so let me not say that. Being able to see this helps us understand exactly where in your application this statement was generated, right? So if I didn't have this and I just had this, if I'm not familiar with that application because I'm just updating it and I didn't write it myself, or if I did write it but there's just so many parts to it I'm not sure, I might not know where to look in the code to figure out if there was a problem with this part of my application. So this can help us narrow down where you need to look. Okay, so we're gonna try to do a demo. Bear with me. And I have a feeling I will need to, yep, I'm gonna refresh this real quick. But what I'm going to show you is, that looks a little bit wonky, but we'll try. So what I want to show you, hang on one second, see if I can get this working. There we go. All right. So there is a sample. This is straight from the GitHub repo. There's a sample in the Python section that I think is beautiful in its simplicity, because all it's doing, it's not using any of the ORMs really or anything. All it's doing is enabling SQL Commenter. I'll just come point. That's possibly easier. There's this, ignore the squigglies, it's doing its own thing today. You can see here where they're importing Comment Cursor Factory using that SQL Commenter library, and then the other place where that's then, let me scroll. The other place where they've updated this is to add this here, and what's happening here is there's these with parameters, with database driver, with open telemetry, with a bunch of other things, and that's telling SQL Commenter which parts you want enabled, what things do you want to be stuffed into the logs. And that's all there is to it. I'm gonna run this one in a second so you can see what is generated, but here is an example of like, well, what if I'm not building something from scratch? What if I've got an application and I just want to start using SQL Commenter with it? So this is, I know this is tiny. Let's see if we can make it a little bigger. So this is an application that's using, I think it's using Connects. So it's a Node application, yeah, Connects. And this is a sample from like the Google Cloud SQL Postgres samples. It has nothing to do with SQL Commenter in and of itself. But what I did is just enable SQL Commenter in here. So I did have to do npm install, blah, blah, blah. You can find what the particular packages are in the documentation. But once you've done that, there's just two things that you have to add. So you have to add this right here. This wrap main connects as middleware and then require that package. And then down here, the only other thing I had to add was, this app.use. And similar to what we saw on the other one, there's options here to tell it what pieces of information you want to go into the comments. So in this case, we're doing trace parent, trace state, route, and database driver. You can define arbitrary key value pairs if you want. There are certain ones that are like just kind of included out of the box or supported out of the box, but it really is up to you. Like, let's say you wanted to do, you're testing two different versions of an application and you want to have that in the logs in case one of them is, doesn't go well, and you want to be able to tell which version of the application those queries were coming from. You could put all sorts of things like that in there too. So I'm showing you this one just so you can see how you could enable SQL Commenter in an existing application. But over here, this is a sample that was written just to demonstrate. So it's very simple. All it's doing is making a bunch of statements. I think it's just looping through and doing like select star from names. So not terribly exciting, but you'll be able to see what's happening. And all that's really coming through on this one is the open telemetry data and I believe some of this database driver information. So let's see if we can get this to run. So I have a database already that we can connect to, and I've set up some environment variables. So if all is well, we should just be able to run the sample app. Okay, that looks good. So this is just logging a whole bunch of stuff. But what's, I think, more interesting, let's see if we can do this in a way that is visible for you all. All right. I want that to go away. That's a little better. Can we pull this? No. Okay, well, I'll scroll over and show you the exciting part. So these are our logs. I've got the log statement set to all in my flags so that I'm logging every SQL statement. You don't have to log every SQL statement, but for the purposes of showing you what this is doing, that's particularly helpful. Oh, goodness. Okay. Is this going to aha. Okay. So if I expand one of those, I'll just come over here and point. So you can see we've got the log. It kind of looks like the example I showed you. We've got the log. there's the statement, and then here's the comments that it has inserted. So it's got the DV driver equals, that's a whole lot of unreadable stuff, but you could, decode it and get something useful out of it. Database API level, thread safety, driver, param, all sorts of stuff. And then there's that trace parent information that was inserted. So, okay, maybe that's useful. Maybe you want to import that into some tool and do something with it. But you can also see it. This is CloudTrace. I'm using this just because I have it available. You could use it in another tool. And if it's doing what we want it to, you should be able to click in here and see, see that information pulled up here. So you can see our select statement, tells you it's a Cloud SQL query, and then you can see as labels that information that came through from SQL Commenter. So that is effectively how it works. If you go into, I'll just do this, make it bigger. If you go in here to the documentation page, there's lots and lots of good stuff. If you want to learn more about this, talks about the format. This is the spec page right here that talks about common escaping, and all the things you could need to know are all in there, but there are also examples. So if I go into Python here, it'll show you how to use it for each of these supported frameworks or ORMs. So if we go to, let's say, SQL Alchemy, there's some good examples in here of like what packages you need, and then also how to actually enable it in your apps. All right. I'm going to switch back over for a second. Actually, before I do that, so got ahead of myself there. Is it here? One thing I'm not showing you today, because the talk isn't really about this, is how Cloud SQL has integrated the SQL Commenter information into the product. It's doing that in a way that helps all of this stuff show up visually. I'm going to just show you the documentation page rather than do a full-on demo of it. And if it looks like something you want to play with, you can. This is like what I would love a future world to look like, where lots of other databases that aren't just Cloud SQL have this kind of visual information for folks to use for troubleshooting. So this is what kind of like the dashboard looks like. You can see all of these metrics plotted out. And then there's this table that has the queries, which, okay, that's cool. But it also has this tags, and that's where the application tags show up. Let's see if I can find you an example. Yes, so, ooh, it's super tiny, but I'll tell you what it says. So there's the tags here. So it's got the action controller route information. If you kept scrolling, you'd have database driver and all of that. And so you can see like which of these, lines in the table basically, but combinations of action controller route are causing the most load or causing the most, there's several different metrics that you can look at. I think it's CPU, IO weight, lock weight, all of these things that you can filter. And then if you click into that, you can actually get query plan samples. So let me see if I can find you an example here. Something like this. It's super blurry on the screen, but you can come in and see stuff like this. So I think that's useful. That's something that today is just in Cloud SQL, but I would love it if we could see stuff like that in some of the other tools that are out there. I think that would really help make this even more accessible and less intimidating to folks who are not experts in all of these things, but need to be able to troubleshoot. Okay. So I said I wasn't going to talk about it. I talked about it a little bit just because I'm excited. Okay, so I want to share resources with you all, and then we have plenty of time for questions or anything like that. The documentation for SQL Commenter is here, and I'll share these on Twitter after because it's not easy to write down all of this. The GitHub repo currently is here, but this is where we think it will eventually be. There is a copy of SQL Commenter there, but I'm honestly not entirely sure of where the updates are being made at this point in time, but I'm pretty sure it's still up at this top one. If you want to hear more about SQL Commenter and OpenTelemetry and kind of like how we see those two interacting in the future, there is a good podcast here. with Nimesh, who's the product manager at Google Cloud, who works on this, and Morgan McLean from Splunk. And then Cloud SQL Query Insights, if you're interested in that, there's a link to the documentation. This is for Postgres. It's also supported now for MySQL, I think, at least in a beta capacity. All right, so I'm not going to go there yet. So before I go to that, does anybody have any questions? Or does anybody think this is not useful? Because I would love to hear that. Yes?
Thank you very much. It's looking very interesting. However, for reasons we are usually not configuring our databases to log the SQL statements.
Yeah.
Are you aware of any other solution for, let's say, Postgres to extract this information?
I'm not sure, but I can find out. I know that, I don't know off the top of my head, I don't want to guess. So I will, if you find me later,
Thank you.
I will find out for you and let you know.
Thank you.
Thank you very much for the presentation. One question, is there, so I noticed Golang wasn't one of the supported languages. Is there any plans on making Golang supported?
So I don't know if there are specific plans, but you're not the first person who has expressed interest. I think there's a feature request in the issue tracker for it. The more interest that there is, the better chance, of course, of either somebody at Google who's on the team who worked on this or somebody else putting something like that together. So yeah, I would go check out the issue tracker and see what the conversation looks like there and add your thoughts to it.
Hi, thank you for your presentation. I have one question regarding the graph that you showed us.
Mm-hmm.
Basically, I just saw that there are some paths that are bigger than others. So basically, you are tracing, but also you are profiling, right?
I'm sorry, can you repeat that part?
Basically, you are tracing, but also you are profiling the request. For example, if a request takes more resources than its path.
Yes.
Okay. Okay, yes, that's quite cool. But to have both the tracing and the profiling, it is really, really cool. Thank you.
Yeah, so, and I think in some of those cases, the information, like there's, information in the logs on like how long a query took is there already. So in some cases it's pulling that, in other cases it's pulling information more from the database engine itself.
Okay, thank you.
Mm-hmm.
Questions? Guess not.
All right, well, thank you. So I do have a favor, and feel free to just get up and walk out if you don't want to do this. So do any of y'all know what Flat Stanley is? No, okay. So this is well known, I think, with kids in the US at least. So it's a book where this little boy sounds really weird. This is going to sound weird. He's laying in bed and his bulletin board falls on him in the night and he's flat. And so he can do lots of things now that he's flat. So he can like slip under doors, but he also can mail himself all over the world. And so he has all these adventures going all over the world being flat. And I have a 9-year-old daughter, and her teacher made a flat Miss Chapman of herself, and she asked me to take it on this trip. I just wanted to see if any of y'all are not opposed to having your picture taken in the background of me holding up flat Miss Chapman. I would love to get a photo. It won't go online. It would just be shared with a 3rd grade class. So if you don't want that, I totally understand. But if you don't mind, I'll do that after we're done. It would make my day. So totally unrelated to any of this, I realize. All right. I'll give one last chance for any questions before that. All right. Well, thank you so much. I really appreciate it.
Thank you, Jen.
I know this is silly, but
let's get started again. So yeah, we have Ida and Mario, and they'll be talking about accelerating development with the Devfile format, which is kind of an intriguing title, so I'm looking forward to finding out what that is about. So yeah, thanks. Take it away.
Thank you. Hello, and welcome to our talk on the Devfile format and how it can help accelerate software development. I'm Ida, and I'm a product manager from AWS Developer Tools, and this is Mario.
Yes, I'm Mario Loriedo, and I'm a developer and a senior principal software engineer working for Red Hat. And I'm Italian, I'm based in France, and yeah, and work on developer tools at Red Hat.
And both Mario and I, we are part of the open standard Devfile community. And we are excited to be here today to introduce you to the Devfile format and show you what kind of positive impact it can have on the daily workflow of developers, making them much more productive. So at the core, the ethos of the Devfile format is that it should be an automated process to be up and running in a development environment. It should be sort of an on-demand, immediate experience to be in an environment so you can dive straight into writing, testing, and debugging code. Unfortunately, this is not really the reality that we have today. It's become very normal for the application to be cloud native, but we still have developers sort of left behind working on local static compute. They have severe configuration overhead and daily upkeeping of their development environment. So what we, of course, want to do is also look at the other problems that we have when it comes to local development environments. So all this, the tooling that you need to contribute to a project, they're version specific to a project. So this effort of getting set up is not just a one-time experience. Every time you want to switch to a new project, you're again stuck with this manual setup. And even when you have the best of intentions, the configuration of your environment starts to diverge between team members. And this inconsistency that you have among team members makes it even harder to collaborate on a project. Code really shouldn't behave different depending on which developer picks up the code, but still today we hear this sort of old phrase of "it works on my machine" way too often. Also, with the Devfile, we have a chance to modernize the way that developers work. It's possible to take the classic benefits of the cloud, of speed and automation, and apply them to development environments. So when vendors of remote cloud development environments choose to use the Devfile as their sort of format for the configuration file, they are able to give developers environments with the click of a button. And since we now have the environments living remotely in the cloud, it's also possible to never slow developers down because it's possible to easily scale the compute and memory of whatever action that's compute intensive that goes on in the development environment. So this means that all these problems, we have a solution to it by the Devfile format.
Yeah, so we have seen those problems. If you have been developing, I think you're used to. Those are frustrating parts of our work. So we've been thinking about how to make it easier and identify some way to solve those problems. And the main idea is to make development environment as code, so to define them with a source code file that can be versioned with your project. So and the idea is that we need to make them repeatable, so the development environment need to be repeatable through automation rather than configured manually and error-prone. They should be short-lived and purpose-built, so you don't need to continue updating your development environment. You just can you can just start a new one when you need to switch to a new branch or to a new project. You don't need to use Git or try to install some dependencies of your new project or your new branch that will conflict with the old dependencies that you had installed locally. And the third thing is, so what Ida also introduced is development environment should be scalable. Sometimes you need more memory that your laptop has, or more CPU. With your laptop, it's hard to scale, so you need to buy a new one or to buy more RAM. On the cloud, it's much easier. You can scale with a few clicks. So this is to introduce the Devfile. So the Devfile is a file format, so a YAML file that is supposed to live with your source code. This is an example of a Devfile used for Go development. It's really a simple one, the simplest Devfile that you can have. Just have an image that is referenced is the default image for Go, and it's in the, you can find it in the source code at the root. Call it .devfile YAML. So this is the convention that we're using. But the Devfile specification has more fields, much more fields. So the first one is the version API, the schema version. So it's possible to, since we are making evolve the spec, we want that every instance of a Devfile specify exactly what version of the spec it refers to. Second part are components. So it's probably the main part of the Devfile. Components are mostly containers. There are other kinds of components, but the main one are containers. So it's a matter, so you can specify the image, but you can specify also the entry point of the container or the CPU memory that it requires. So everything that you would like to specify when you run your development tools in the cloud. Third section are commands. So commands are usual command line that you run to build or to test your application so that people don't need to figure that out and do that manually. If the Devfile is used by an IDE, the IDE can automatically have the command from the UI, so you will be able to use it. So these are like the command to build so that are used by the developers for that given project. And then the last one are events. So in the life cycle of your development environment, when the development environment is starting, you may want to start pre-fetching some dependencies or do a pre-build of your application. This is what the events are. So when we have post-start, pre-start events, and also for the end of the life cycle. This is it for the spec, and yeah.
And then to get more acquainted with what the Devfile is, we created in the community this gallery of sample Devfiles that are curated for specific languages or frameworks. This is a great way to get started with the Devfile, to get acquainted with it. You can use them as is, or you can use them as a starting point or a baseline that you can then further customize so it fits your specific project. But this is a great resource to get started and get familiar with what a Devfile is. And with that, I think we're going to head over to a demo that Mario's going to do using this sample application called the Sock Shop.
Yes. So we took as an example a microservice application that has multiple services. And what we would like to show is a Devfile that allow you to do development of one of the services here. And we choose the front-end service. So this is the WeWork microservices demo. We haven't invented anything about that. We have just added a Devfile to the repo so we could use it to start to provision and a development environment in the cloud. So this is the organization with all the repositories, and there is the front-end one that I fork and where I actually added a Devfile here. And not only I've added a Devfile, but also added in the README this link that allow me to start a development environment from with a click here. So let's just open it. All right, so that will start It will provision the containers that are described in a Devfile. They will be started in the cloud, and we can see here is actually a dashboard. Let me make it a bit bigger. It's running on Kubernetes. This is OpenShift, so Red Hat distribution of Kubernetes, and this is actually the pod where the development environment is running. So now it's say that it's running. So if I go back to my IDE, I can see that. All right, so it has been created. So it's been started. So I have Visual Studio Code running in my browser. We have let me just show you a little bit bigger. So this is so just plain vanilla Visual Studio Code. It's running in the browser, but it's exactly the same source code of Visual Studio Code. We're just repackaging it and running it in a container with some. So we usually continuously rebased it, but the editor. So we'll see that later. Is not defined in the Devfile. The Devfile is really decoupled from the editor that will run. The important thing is that you need somehow to connect to that development environment, and Visual Studio Code in this case is the way to connect to the pod and containers where I actually have my build tools. So if we go back, so if I've cloned here the source code of the front end, and there is a Devfile. So the Devfile is here. You can see that it has one component for the front end. It's a container with that is related to is actually the microservices demo front end that is based on the Dockerfile dev that I've here. So it has a Node.js, so I will be able to actually start the front end from the command line. Something else that I wanted to show is the source code. I can just open this JavaScript file, and I can show that so here it's Visual Studio Code, so there is the TypeScript extension that is already included, so I don't have to install anything here. But I have code completion. If I do that, and I can. So this is classical thing for IDEs. You also have you are able to see like documentation or the definition. I can navigate to the definition of the code, etc. So it's really Visual Studio Code, but running in your browser tab. And I didn't have to install anything locally. Didn't have to install Visual Studio Code. Didn't have to install Node.js, and I was able to have that on the fly. Other thing that I wanted to show is that so not only you have the code, but you're also able to run. So you have a container with Node.js. And I have the definition of the command in my source code. So there is a command that is used for debugging the application that is defined. So I can just click here, and it starts my Node.js application. And once the Node.js application is started, actually there is an extension that see that there is a process that is listening on this port, and this port is a port that I had defined in my Devfile. So when you see the process, it's asking me if I want to open the application on a new tab. And this is our example application, our microservice application that I'm able to run from my browser through the Devfile definition. And let's make it shorter. So another cool thing is that you can, for example, if I go back to my catalog, and I can put breakpoints here. So if I go back to the application, I click on catalog, and I see here there is this red dot. That means that the breakpoint has been hit, and So I'm able, so the application is stopped here, is not running, and I can see the value of my variables. I can add variables to watch, and also I should be able to actually have, so for more complicated variables, I can really navigate from the IDE. So this is classical Visual Studio Code anyway, but it's cool to be able to do that without installing anything locally and running it in the browser. So I can continue the execution. And I think that's basically it from development lifecycle. So the other thing is that, yeah, you get extensions that can be installed with one click. So they get installed, and you're able to have extensions, all the extensions that are published on OpenVSX. So we're not able to use the Microsoft marketplace, Visual Studio Code marketplace, but there is an OpenVSX that is an open marketplace that we're able to use. So we're able to connect to that. There is also source code. So I'm already logged into GitHub with my credentials. So I haven't seen that, but the first time that you start a workspace, you are asked to authenticate with GitHub. So I'm able to commit with my user, and yeah, I think that's basically it from the demo point of view.
And I think typically with automation, like the cool stuff is all the stuff you don't see. So this was truly just a click of a button, and then a bunch of stuff goes on in the background, and that's just been offloaded to somebody else to handle. So you just get that immediate experience where you're up and running and ready to code. And by having this Devfile placed in the repo, as a team, you start to collaborate on a single source of truth. So anybody who creates a branch to start contributing with fixing a bug or developing a new feature, they are truly now working in copies of the same environments, so they can have this sort of sense that they're not sort of diverging and going off in different directions for what they're working on, and how they're all contributing to the same application and bringing customer value to their end users.
Okay, so now we have seen the Devfile, we have seen the demo. We want to talk about how do we translate this Devfile into a development environment in the cloud. So what I've just shown is on Kubernetes. So Kubernetes is the platform, and we use something that is called the Dev Workspace operator. So it's a Kubernetes operator that provision development environment. And I have another talk later today just about the Dev Workspace operator, so I won't talk too much. But the idea is, from the Devfile, the Dev Workspace operator creates a workspace pod, so a pod with containers and services that will allow a developer to connect from their browser and to just code, build, and test their application, so the inner loop. But that's not the only platform they supported. There is also Docker. So there is a plugin for Docker that allows to transform a Devfile to transform it to provision development environment in a VM that only has Docker installed. So no need to have Kubernetes in this case. And that's something that Ida's team has been working on. But the result is the same. You will have the same containers that will be started, and the developer will be able to access from their browser or from their local Visual Studio Code that can connect remotely, or IntelliJ, local IntelliJ can connect remotely to the container to use the power and the tools, repeatable containers that are where the development tools are running. So it comes to the IDE support.
Yeah. So what's nice about having these cloud development environments is that we are taking the traditional IDE that's a desktop and a little bit of a monolith, and we're splitting it into two. So you have the remote backend up in the cloud, and then you can sort of reduce your IDE to be a thin client that can run in the browser or still on your desktop and connect to this remote environment. And when you start working in the developer space, you quickly realize how passionate developers are about their favorite IDE and their preferred IDE. So at least for me, this is a great example of how we can sort of respect and meet developers where they are. If they've been coding in IntelliJ or a PyCharm or VS Code for the last 10 years, and that's their comfort zone, they can keep that experience, but really enhance and modernize it by sort of offloading the sort of heavy lifting of the environment to the cloud. And just on a final note here before we take questions, recently the Devfile became a sandbox project in CNCF. As you can see, Red Hat and AWS are active members of the community. We also have JetBrains. JetBrains is the vendor behind Golang, PyCharm, and IntelliJ. They have also started contributing to the spec of the Devfile. And of course, if you're curious to learn more, if you want to be part of the community, you're more than welcome to join us. We have a bunch of ideas and sort of plans for how to enhance the spec in the future. So come join us if you're interested. And I think that leads to some time for questions.
Thank you very much. It's an awesome project. I was wondering, you're trying to minimize the divergence between environments, right? So people are describing their workloads in Helm and customize or plain Kubernetes manifests. Isn't that bound to diverge then again if you're using dev files like next to it?
Do you want to take that one?
Yeah. Okay. So I haven't shown that. So we haven't shown that before. But if we go back to the spec, so you see the second is the component part. And component part, we have here one example is container. And it's one example. But we have another type that is Kubernetes manifest. So you can just reference a Kubernetes manifest from here. So the idea is to really not to, so to reuse the tools like Compose, Docker Compose, or Kubernetes manifest or Helm charts. Currently in the spec, we support Kubernetes manifest, so containers, Dockerfile, so you can link to a Dockerfile that get built and run. And we want to support, so Compose file is the thing that is, I've heard more about, like ask for support. But from a spec point of view, that's kind of easy to add that. Then we need to implement, so we need sometimes to support Docker Compose, for example, on Kubernetes, we need then to transform a Compose file in Kubernetes, so pod services. But yeah, there are libraries for that. So the idea is really to make it extendable with the files that already are in the source code repository.
Got that. Great.
And that also comes back to that we're trying with the dev file not to come up with yet another file that sort of ignores the rest of the landscape. So we're really trying to have this bridge between sort of the classic inner loop and the outer loop and not have them so disconnected. So whatever configuration or recipe that you use for your outer loop, we want the dev file to be able to understand and interpret that and sort of make a superset of it and have those extra tools you need for development purposes.
That's cool. I get that. Well, sometimes when you like have like the microservice architecture and you're using like cloud services like Lambda or S3, how does that fit in?
Well, this is where we also have to differentiate between sort of the running application infrastructure that you get sort of copies of versus the environment. So we do also have plans to evolve the Devfile spec, so you can have like a Terraform or whatever infrastructure as code that you use for your application infrastructure, that you can include those references, so you not only like push your development environment to the cloud, but really can also get a full-blown environment with the running services that then provides you maybe a downsized Lambda or gives you access to the S3 buckets and so forth.
Great, thank you.
More questions? I guess not. Yep, thank you very much.
Thank you.
And we have a small break now, so be back here at 11:40.
I need you.
Dance with me. Dance with me. Dance with me.
I need you.
Dance with me.
I need you.
Dance with me. Get sexy.
I need you.
Dance with me.
I need you.
Dance with me.
So, welcome back from the small break. We're going to start with the next talk. So we have Adrian, who will talk about container checkpointing and what's next now that we can do it. So yeah, take it away.
Okay. Thank you. Thank you for having me here. So my name is Adrian Reber. I work for Red Hat. I'm involved in process migration, which is the basis of container migration for at least 12 years now. Since 2012, this is always using the tool CRIU to checkpoint restore processes and containers. And since 2015, I'm mainly focusing on checkpointing, restoring containers and migrating them. So the agenda for today's talk is I first want to talk a bit about the background, about checkpointing, where it came from, how it is used, and more about how it's used in the use cases. I want to give a few demos, how you can use checkpoint restore with containers. And then the last point is what's next, especially in the context of Kubernetes and how we want to continue with checkpoint restore there. So as I mentioned it, today is everything I'm saying is about CRIU, checkpoint restore in user space. The name for CRIU in user space is because in the early 2000s there were approaches to get checkpoint restore running in Linux, and they were different approaches. One was an external kernel module, which was never merged upstream. Then there was a library intercepting system calls, all different things to get checkpoint restore running in Linux. And then there was an in-kernel approach to do everything in the kernel, which would be nice for the user. But the patch set was about 100 patches, and it was touching almost every subsystem of the kernel, so the kernel maintainers didn't really like it, and it wasn't merged at the time. I was working with that patch set at some point, so it was able to checkpoint restore processes with that patch set, with that completely in the kernel that was working. But as it was not accepted, a new approach came, and because the previous was in the kernel, the new one is in user space, and that's how CRIU got its name, checkpoint restore in user space. There are multiple integrations of CRIU in existing container engines, runtimes, orchestrators, and I think the first one I have to mention is the integration in OpenVZ. The company behind it, they wanted to migrate containers. They had a solution to migrate their containers, but they were using implementations which were, again, not upstreamed in the kernel, and so they wanted something which the whole community could use, and so they started developing CRIU, and that's how we got CRIU, which also means CRIU is focused on containers in contrast to many other checkpoint restore implementation, which were coming out of the high-performance computing area. So CRIU is for containers. One interesting integration of CRIU is used in Borg. That's Google Containers Engine, and we upstream CRIU have been told by Google at a couple of conferences how they use it, and what they basically do with the containers is for long-running containers, they use CRIU to migrate those containers to other nodes if the current node has low resources. And so before migrating containers, they just killed the container and restarted it somewhere else. All the work was lost, and now they just migrated from one node to another. And the work done in the long-running, low-priority container continues. From what we've been told, this is things like YouTube video recoding, things like this, which are running in the background and which have no interactive users. They said they also tried CRIU for interactive sessions where people are using, I don't know what, maybe Google Mail or things like this, but the downtime during migration is like 3 to 4 seconds, so it's too much to use it for interactive sessions, because then it would just hang for a couple of seconds, and they don't want that. Then there's CRIU integration in LXC and LXD for a long time. They started very early to integrate checkpoint restore support there. Then it exists in Docker for a couple of years. Then there is also integration in Podman. This is something I have been working on for the last couple of years to make sure CRIU works in combination with Podman. And the work in Podman was kind of a preparation to get it working in CRIU, the container engine. And this is the pull request where I'm now working almost 2 years now to get it merged into CRIU. And the problem is not the CRIU developers don't want it. It first has to be merged in Kubernetes so that the CRA API is updated. And once that's there, the changes can be added to CRIU, to the container engine level. So there's a ticket in Kubernetes. It was opened in 2015, and it was asking for container live migration. And so it's now 7 years that the ticket is open, and it's still not possible to migrate containers in Kubernetes. But my hope is with the work we are currently trying to do, maybe we are getting a little step closer to container migration in Kubernetes. So the current situation is, when I wrote a proposal, I said, now that we can checkpoint containers, what's next? So at the time I wrote a proposal, so to get something into Kubernetes, you have to write a Kubernetes enhancement proposal. And so I had an enhancement proposal and a code. It was already to be reviewed and merged, and the cap was merged, and my assumption was if the cap was merged for the release 124, then the code would also be merged for 124, but it wasn't merged until the last day, and so the title is not totally correct, but I have been told that it will be merged for 125, an early merge, hopefully, and so the first link is the cap that was merged, the second link is the pull request to update a cap from 124 to 125. And the third link is the actual code change in Kubernetes to implement checkpoint restore. We are calling it forensic container checkpointing because the idea is we want to start with a very small use case of container checkpointing to not introduce too much changes at the same time. The forensic container, the idea behind forensic container checkpointing is that you have a container, you think there might be something not correctly working or it might be under attack. You can take a checkpoint of the container without the container knowing that it was checkpointed. It will continue running. You can take the checkpoint and analyze it in a sandbox environment somewhere else. Even if it's called forensic container checkpointing, in one of the demos I will show later how forensic container checkpointing can be used to migrate a container from one Kubernetes host to another host. So that's possible with the current state of the cap. So the next thing I want to talk about are a couple of use cases. Why to use container checkpoint restore. Container checkpoint restore is a bit of it's not what you think, what you expect from a container, because the idea of a container, it's stateless, you can stop it, you can kill it whenever you want, and it has no impact on your data, state, whatever. But the truth is that there are containers that are stateful, and if you can checkpoint them, it can make your life easier, maybe, hopefully. So the first use case is reboot and save state. This is a really simple use case. I have a system, there's running a kernel, that's the blue kernel, and there's running a container on it, that's the red thing, and now I want to reboot the system, but my container takes a long time to start up, so I really don't like to rebooting the system and have to wait like 5 minutes until the container is ready again, because it needs to read a lot of data from disk and initialize libraries, something like this. So what I can do is I can upgrade the kernel of the system, for example. I can take a checkpoint of the container. The container is now written to disk. I can reboot the host. The host comes back. Now it says a green kernel, so it's different. And then the container is restored and keeps on running just as before. So now to the demo. So I'm demoing this using Podman, but For Kubernetes, it would be difficult. I could do it on the CRIU level. At some point, I had checkpoint restore implemented in kubectl drain. So if you do a kubectl drain on your local node, all containers were checkpointed. And on startup, they were all restored. But this was all in previous proof of concept. So Podman has it working out of the box right now. So that's why I'm showing it in Podman. So I say Podman run. My container, it's a really simple container. The important thing, it's a stateful container, so I can access the container by saying, accessing its IP address. So it returns a number and increases it, so it's stateful and really simple. So now I say Podman container checkpoint L for work on the latest container. So now the checkpoint has been created. Now I'm trying to access the container again. It doesn't exist anymore because it was stopped. And so now I will just reboot the system. So this system is a RHEL 8 something system. And the other demos are running on Fedora 35. So it seems it's up again, really so fast. Yeah. So trying to access the service, it's still not running. Now I can say Podman container restore latest. The container was restored. Now I can access it. So it's now continuing at the state it was before. So this is the one use case. The other use case is quick startup. It's again, same thing. You have a container which takes a long time to initialize and you want to start it faster. So what you can do, you can wait for the first initialization, create a checkpoint of it, and then create multiple copies of the same container in your system. So we've been contacted by, what was it? I think, yeah, MATLAB. So MATLAB has something as a service. And they actually, currently, they do checkpoint inside of Kubernetes privileged containers, complicated way, but because their container takes like 5 minutes to start up, and with checkpoint, they can get it up in like 5 seconds, so the customers don't have to wait if they start their containers from the checkpoint. Same host as before, so now I have, again, my container running here. Now I say Podman container checkpoint latest, and then I say keep running because I don't want to stop the container I'm checkpointing. And then I'm also saying I want to export the checkpoint to a file. Keep running. Okay, it's leave running. Leave running. So now the original container still is running. I can access it. 567. Now I can restore a copy of the container. Container restore import. So this will now fail because the container engine does, it tries to restore the container with the same name and the same ID. This doesn't work because it's still in use by the original container, so we can just say we want to give it a new name. We call it counter1 and counter2. And now we should have 3 container running. Yeah, we have the original container and counter2 and counter1. And now I can access all of them. I can say counter1, it continues from 5.6, and counter2 also 5.6, and the original container is also still running. So that's how you can create copies of your running containers, and if it's taking a long time to start up, you can skip the long startup time. And a combination of all of those use cases kind of is the container live migration. So you have a container on your source system. You want to get a stateful copy of the container to the destination system. So again, you take a copy of your container, you do a checkpoint, transfer it to the destination system, and restore it multiple times. And I have So it's still running here. So I have Kubernetes running here, and there's no container running. So what I want to do, I want to run a pod with 2 containers, and I want to checkpoint this container and transfer it to another system. So this system is now not running locally. This is like 1,500 kilometers away, and I want to do a stateful migration of the container from Kubernetes far away to my local Kubernetes in the VM. So I will start this pod. So I just say, I cannot see it, apply. So now it will probably create the containers. Yeah, so there's the first container. So I have actually 2 counter examples. So the Wildfly is in Java, and the one I'm migrating is in, oh, interesting. And the one I'm migrating is in Python. So now I cannot, so there's this one, okay. So I can access the container. I can again say curl. And then I say, try to get the IP address. So it's the same thing. It says counter 0, counter 1. In addition, it reads a file which is locally mounted from the host. I can write something else to that file. So the file is on my host, and it's bind mounted into the container, and then it just changes depending on what I have here. So the content of the file will not be migrated because this is specific to the host the container is running on, but the container will be migrated, and the state of the container will also be migrated. So to migrate a container, or to checkpoint a container using the forensic checkpointing implementation. So what we have done is the decision was to make a kubelet-only API to checkpoint a container. We haven't extended it to kubectl because the implications of taking a checkpoint are not totally understood yet, probably. The problem is if you take a checkpoint, you have all the memory pages on disk, and if there's a secret in the memory pages, then you now have them on disk, and maybe it's now easier for someone to access those. So currently it's a kubelet-only API. It's called checkpoint. Then we give the namespace of the container, then the pod, it's called counters, and then we say we want to checkpoint the container counter, and then we tell it to write it to an image called localhost checkpoint test 15. And now it's creating the checkpoint, and if I now look at the images on my local system, I see there is now a checkpoint image in my local image store, and it's 8 megabytes the checkpoint, so it's not a big checkpoint. And now I can just log into a registry, and then I will push the checkpoint. It's called 15 and 15, so this will now push the image to a registry. And it's pushed. And now so this is now the remote system, Fedora 2, and now I'm switching to Fedora 1. No containers running, and I have, again, a specification here where I'm starting again a pod with 2 containers. One container is still the original container from the registry, not a checkpoint. This is the Java counter, and the other one is now the checkpoint image in the remote registry, and I will change this to 15. And now I will say apply and CRIU control PS. Okay, so the first container has been started. Now it's probably pulling the checkpoint image. Come on, do something. Ah, okay. And so now I see it has created the second container. This should be from the checkpoint. And if I now access this container, now it's called FE6F. So now it shouldn't print out counter 0. It should print out counter, I don't know, 5 or something like this, 4. So, and this is again, the prefix is coming from the local file here, which is on the system. I can change this again. You see the bind mount is specific to the host and the state specific to the container, which was migrated. Okay, so this was the container migration use case. And now to the actual topic of the talk, what's next? So currently, assuming that I was told that the cap and the code will be merged soon, so we can migrate, kind of migrate containers. So we can checkpoint containers, and with the trick to use the run command to automatically restore a container. If it's a checkpoint image, we can migrate containers. So the next thing would be, we thought about is maybe we need to extend the checkpoint command to kubectl so that you can actually checkpoint a container without going to the kubelet API. This is one of the things we want to discuss with the community next. So then there is another thing which we initially thought about. We were talking about a restore command. So at this point, we are not sure if we actually need a restore command for containers at least, because it seems to work pretty good if we just go through create and start to restore a container. There seems no longer a reason to create a restore command. This was initially an idea we had, and then the next big step was to checkpoint restore complete pods. So this is with the pull request I mentioned of CRIU. This already works in CRIU. It's a pretty simple process. We just loop over all containers in the pod, checkpoint them all, collect some additional metadata for the infrastructure container, and on restore, we recreate a completely new infrastructure container with the shared namespaces it had before, and then we just restore the pods in the shared namespaces. This works pretty good at this point, I would say. So the problem is, to restore a pod, we would need to think of a new way. So either because I don't think it's possible to specify an image to a pod in the pod specification YAML file. So we would need to have a separate restore command where we can tell Kubernetes, so I'm giving you this image of a pod, and this contains everything you need to know about a pod. Just tell it to the container engine that it will do the right things, something like this. So, and then we, of course, need to correctly push the pod also to an image registry or something like this. So this is more the future, which we haven't thought about so in clear steps yet. So then at some point we could think about a kubectl migrate command where we can say, okay, I want to migrate this pod from this node to another node without going manually through the registry, so that some tool does it for us automatically. And the last step would probably be the scheduler integration. If this all works up to this point, maybe at some point we can have the scheduler decide, okay, resources are getting low on this node, there's a low priority pod running here, I'm just migrating it to another node which has more resources, and the container doesn't have to be stopped and lose state if it's a stateful container. So with this, I'm at the end. So this is, the summary is CRIU can checkpoint and restore containers. It's integrated in different container engines and runtimes for a long time now already. It's used in production. The use cases I show was reboot into new kernel without losing container state, start multiple copies, migrate running containers. This is all waiting on the final approval of the cap for 125, hopefully. And currently, we are restoring using the run or the create and start command. Thanks for your time, and if there are questions, I think we have a bit.
Hi, Adrian. You mentioned a few times that this is implemented in CRIU, and looking through the PR, it seems like there are changes to the CRI API. A few new methods have been added. So my question is, how much work would you see we'll have to do on the containerd side, for example?
So containerd has support for checkpoint restore. They also have support for pushing checkpoint images to the registry. We initially looked at those images to maybe reuse what containerd was doing. The problem is containerd is including protobuf specifics from containerd, and we didn't want to depend on protobuf definitions. We also discussed this, or we thought about it internally with to maybe have a standard how the image could look like, make it based on JSON or something which doesn't depend on some external definition, something like this. So containerd already can do checkpoint restore. So I guess, so I don't know if containerd handles checkpointing pods out of, handles checkpointing containers out of pods correctly, and especially restoring into pods. But the thing is, the most thing you have to do is basically tell run C, okay, this pod needs to be restored in an existing namespace, don't create a new one. And so I would say the steps to have it working in containerd are not that big, because containerd already knows how to handle checkpoint restore. It's just, yeah, we have to think about the image a lot, I guess, to have it working with all runtimes, engines. And this, from my point of view, this is only about metadata parsing. It's not a really technical problem. And so it shouldn't be too difficult to get it working in containerd.
More questions?
The container must be migrated to another node in the same Kubernetes cluster, or it
oh no, this was I'm not Kubernetes experienced enough, so I'm just checking out Kubernetes. I'm saying local up cluster, and I'm starting one cluster here and one there, and they have no connection at all.
Cool. And the changes to the rootfs are not migrated, right?
Yes, they are. So nice. This is a difference to the thing what containerd does. The Podman and the CRIU image contains all changes to the root file system. So we basically go through the list of if you do a diff of the container, you get a list which files have changed, and we include all changed files in the checkpoint image. And on restore, we tell the container or the container engine downloads the base image the container is based on, then it applies the rootfs changes on top of it, and then it does the restore of the checkpoint, of the container here.
And one more question. If the container is using user namespaces with some mapping, you keep the same mapping when moving it to another host?
I don't understand what?
Like, let's say the container is using user namespaces.
Okay, yeah.
And it has one mapping.
Okay, we are restoring all. So if you have shared namespaces, then of course we restore into the shared namespace. If you have a namespace which is specific to the container, then CRIU will restore all properties of the namespace.
Okay. I was asking because we're trying to add user namespaces to Kubernetes too, at the pod level. And we're trying to give pods non-overlapping mappings. But if we migrate and we keep the same mapping, it might overlap with our container existing in the host, and that might break.
Yeah. So currently we are not, so CRIU supports user namespaces, and we have tests on the run C level running to make sure that user namespaces work correctly. But I think neither Docker nor Podman, if you use it as root, is using user namespaces. So the user namespaces support in CRIU does not get a lot of exposure. So It works in theory, but because nobody's using it really, so we don't see any bug reports, or maybe it's, I don't think it's error-free, so I guess nobody's using it really.
Yep. Okay. I guess no more questions. So thank you very much, Adrian. And
thank you.
So, yeah.
For everybody here, there's one more slot for lightning talks. If you have something you want to talk about for 5 minutes, it doesn't even need slides. It would be great to have them. Sign up for it right here. We have one more slot.
Yep.
sexy. Dance with dance. Dance with dance.
I need you.
Dance with dance.
I need you.
Dance with dance. Dance with dance. Dance with dance.
I need you.
Dance with dance.
I need you.
Dance with dance. Get sexy.
I need you.
Dance with dance.
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 All right, so let's get started. So for our next talk, we have Lee here, and yeah, he'll be talking about multi-tenant Kubernetes APIs and how user impersonation is the key to it all. So yeah, take it away.
Thanks, Thiago. Yeah, I'm super excited. Hi, friends. My name's Lee Kapili. I'm going to be talking today about extending Kubernetes in more secure ways. So today's talk is for controller builders. It's for people who want to create projects that allow people to use the Kubernetes ecosystem with new schemas, new tools, and integrations. And yeah, I'm from Colorado. If anyone is totally just not connecting with Kubernetes impersonation mechanisms and auth, this is a picture of my dog, so like that's valuable, and you can take that away. I'm Filipino American, so if you speak Tagalog, hit me up. I have been contributing to the Kubernetes space, and I'm all about GitOps, right? I come from a place of operating container workloads and cloud workloads back from the Puppet kind of era in telcos and with, data centers of computers. We're infrastructure engineers, we gotta glue stuff together, and it's kind of hard to collaborate on stuff sometimes. Right? And so GitOps for me, when I use Kubernetes, it helps me tell that story with my team. Right? It helps me understand the versions and the changes of my config over time with my clusters. And so that's why Kubernetes and GitOps are valuable to me. And so working with the Flux team, because I had the privilege of working with the awesome folks at Weaveworks, we started to kind of refactor things, and now we have Flux 2. Right? There are a lot of Flux 2 users even in this room. Project just keeps going because people are looking to get organized with Kubernetes. It's one of the biggest problems that you have when you want to start using these distributed computers. And I'm on the Tanzu team. So I want to be talking about something that we discovered as we started factoring out Flux into lots of controllers with lots of objects. And it's about building multi-tenant APIs. You see, when we start collaborating with each other, we start using the distributed computers, we're not just like logging into our laptop anymore, right? We need to know about identity, We need to know about roles and access. And so the GitOps problem is actually the problem of like, how do we work with each other? Right? And working with each other, it's very important to know who people are, what they have access to, and there's some interesting things happening with identity when we do GitOps in Kubernetes. And so we had this need for multi-tenant APIs. See, because say you have a controller, right? A very simple one, say something like the deployment controller. It manages deployment objects and replica sets. And then the replica set controller is also making pods and like moving things around for you. All right, so you got like these two different API kinds, and then maybe they have some sub-objects. Right, so you're in the control loop, and it's like, okay, I'm gonna work on this object. It has this specification and produce these objects. Right, so you're changing one API, and then the controller on your behalf, because of the declaration, will imperatively change other APIs. You see, well, in the GitOps land, it's not as simple of a picture, right? We have the same topology, but now we maybe have even more different kinds. Right? We might have like webhook configurations, we might have sources, we might have different kinds for applies. And then those objects, especially the applier, it's not just operating on a fixed set of things, because the applier is hooked up to some source that has configs about all different API objects. But then you might have an applier that's just for your app. It's just modifying a deployment and a service in a namespace. And then you might have an applier that's applying custom resource definitions. It's changing the cluster. It's modifying secrets management. It's doing all these really low-level things. And so these completely different ideas of privilege just based off of changing the specification of the object. Right? Now you're affecting all these other APIs in the control loop contextually for just one request. But then the next request, you might need to drop down to a much lower level of privilege all of a sudden. We have this need for multi-tenancy. And so it's not even that simple, because I haven't even been talking about namespaces. You see, the applier object, right? Say you do a Helm install. Say you do a cap control deploy. Say you want to apply a bunch of stuff from your JSON-net build. You have the applier resource living in the cluster, and then maybe it pulls in some configs from your repository. And then those configs actually apply to other namespaces. So now we're not even just talking about an object affecting multiple object APIs. But then you also are affecting all of these different namespaces, right? This is like, there's many different slices of access that are being played with here. And so we want to really tie in. The first primitive need is that applier needs to have an identity, right? And you can apply this, you can use this concept with any complex object that you're trying to reconcile in your control loop if you're building an extension. Right? So then what's kind of happened is, okay, well, we have this need. And normally when we think of having to restrict access or open up access to the Kubernetes API from some place inside the cluster, we reach for a service account. Right? Because this is just like, this is what we know. And so extension authors, the Argo project, even Flux, Cap Controller, these GitOps tools, they're like, okay, well, let's give people the ability to, when they're reconciling their Git repo, let's restrict them to a particular service account. Sounds like a good idea, right? And maybe we can do that by just giving the controller access to every single secret in the cluster. And then the controller can just pretty promise to go and fetch that token and then be that user for the purpose of reconciling that object. So it's almost like pseudo access, or maybe even dropping a privilege in Linux. Now, there's some problems with this, and I really want to point out that service accounts aren't meant for a control loop to reconcile one object. They're meant for pods. There's actually a bunch of extra stuff built on top of service accounts in Kubernetes that are for pods, right? We build these token secrets inside of like every namespace where the service accounts are, and then you can just like go and fetch those things, and then the pod references the service account and automatically mounts that secret. That's the old way of doing this. We're actually deprecating this in Kubernetes 1.24, which is just released. So if you're depending on this, like we were in Cap Controller, you have to change your code as an extension author. The feature gate for that is called Legacy Service Account Token No Auto Generation. So it's enabled by default. The new way that it's done is there's the token request API, and this is really something that's only built for the kubelet, or kubelet-like things. Not to say that you couldn't use this in a controller, but the problem is that if you're using service accounts, pods are meant to use them. And if you are trying to have a privileged identity, say you have an applier in some namespace and you want to apply some config to that namespace, there's now a service account in that namespace, and any pod that ends up in that namespace can assume the service account. And that privilege escalation mechanism is just not desirable. And so that's my main argument for why we should just not be doing this at all. And the only mitigation there is then if you want your applier object to change config and say create pods in the cluster, you actually want it to apply to a different namespace. All of this stuff is written up in detail in a proposal that I'll link at the end of the presentation. And that proposal is something that I've honestly spent probably the better part of a year and a half on, as well as a bunch of other folks collaborating. So I'll go and give it a read. So what do we do then, right? If we're not supposed to do this, then maybe what are some good ways of handling this problem? And there is a mechanism that maybe not a lot of folks know about, or maybe you only know about it in the context of debugging as an administrator. And it's called user impersonation. If you talk to the API server with some special headers, and you have the permission to do so, you can either impersonate any user in the cluster, or a restricted set of resource names, or all of the service accounts. And so if we then take this mechanism and we say that all of our controllers can impersonate these users, then we can start to create a schema of access, these applier identities that we need. And so instead of, one thing to know about service accounts is that they're actually just users with a bunch of extra stuff on it. Like, a service account is not some special identity inside of the Kubernetes API. Once the pod has used its special token with all those extra mechanisms, it's just seen as the API server by this special string. So it's system, service account, namespace, name. And then say if we wanted to copy this mechanism by like making more namespaced users, we could have the Flux controllers say Flux user, namespace name. Right? Or we could even use the system prefix, but this is reserved. Service accounts also have groups. Not a lot of people know this because nobody binds to them like ever. If you search for this on GitHub, there's like no config. If you are doing this, talk to me. I want to know your use cases. But so instead of doing system service accounts, the group, and system service accounts namespace, we can just also do that for our users. And let's actually do a little bit of a demo. I want to kind of show off some things here. So if we say, I'm on a kind cluster and I'm the administrator, right? So I can do kubectl get pods, right? Similarly, get service, right? So there's a resource there, I have access to it. Now, if I want to do like kubectl get service as nobody, this is using impersonation, right? So here we're seeing now error from the API server, services is forbidden, the user, nobody, cannot list the resources in that API group, right? Now, I want to show you a fun behavior, right? So say I have a fake service account, right? Because service accounts are just names. I have to fix that, actually. It is system service account. Default is the namespace that I'm in, and then fake SA. Right, so I don't have access as fake SA. If I get the list of service accounts, there's nothing there. If I do a k create, I wrote this earlier. So I'm going to role bind, name it fake SA, this doesn't matter. And then the cluster role is admin. I'm going to role bind as administrator into this namespace. The service account in the default namespace. Okay, now let's try to get those pods again. Or was it, it was service. So kubectl get service as system service account default fake SA. Oh, it works. Right, so there's nothing special about service accounts, right? It's literally just a specially formatted string. It's a username. And in the same way, if we want these same sorts of namespaced features with access, we can do that with other names that are well formatted. Now, the problem with using these service account names is that pods like to use those things, and there's the privilege escalation mechanism, so we don't want to do that. The other thing here is just to kind of prove that you can actually impersonate real service accounts, which is what we do in Flux today. I can like impersonate the Flux system service account for core DNS. I don't have access with core DNS, but if I access the service controller, in the namespace default service account. Did I misspell this? Service as, literally just did this. Oh, it's the wrong namespace. Sorry, kube system, not Flux system. So core DNS can actually access the services there. And then the service controller can as well, if I can spell it right. But then I think something like the deployment controller, I don't know if this can access, yeah. So the deployment controller cannot access services, right? And so this user impersonation mechanism is really powerful in that way. Cool. So this is within a single cluster, but we're in a multi-cluster world. Just taking my time here. We're in a multi-cluster world. And so we don't just need to know and solve the identity problem working within our namespaces and with our team, but with Flux, we actually have the ability to manage other clusters. And so then how does Flux have the ability to do that? And the first thing that you might reach for is kubeconfigs. Now, if we kind of follow, there's a trick that's used inside of Cluster API. If you store kubeconfigs in a secret next to your cluster definitions, Cluster API will go and make that cluster, and then it will put the kubeconfig that it created from that cluster into a secret, and then you can use that to do like these cluster apply sets. So you can apply configurations using Cluster API to the thing that you just made. And a GitOps operator like Flux or Argo can go and grab these secrets and do the exact same thing. Right? So we're running a workload inside the cluster. Our reconcile loop can grab the configs from the applier thing, use the kubeconfig to talk outside the cluster to the other one. And so then once we're talking to the cluster, we can still do all of these things with user impersonation, right? But now we're impersonating users in the target cluster instead of the source cluster. And there are some things to be careful of here because kubeconfigs are actually, in my opinion, like super complicated, and there should probably be multiple objects there. And you have to be very careful when you are executing them with the Kubernetes client libraries. You have to sanitize these things. There are some recommendations in the proposal that's linked at the end. And we actually had a CVE, or we published a CVE because we knew that we had this problem, and we just fixed it this month. So that the CVE is, from this month, and it's improper kubeconfig validation allows arbitrary code execution. Something to watch out for if you're extending Kubernetes in this way and need access to another cluster. Say if you were like writing a service mesh or a multi-cluster network policy controller, there's a lot of things you could think of where the objects get kind of complicated and you're also doing things in multiple clusters. Watch out for that. Now, the last bit is really building on top of these ideas. Okay, so we kind of recognize now maybe we don't want to use service accounts literally, but we want our own sort of service user that's very particular for the objects that our controller is reconciling, right? You want a specific context. Now, once we have all of these objects constrained within each other, or within itself, we want to also be thinking about policy between the objects, right? Remember how when we were applying the config, we were working in multiple namespaces, applying config to multiple namespaces? Well, so let's look at this example. We have a webhook, a source, and an apply in a management namespace. And then now that's going to go and maybe make some configs and secrets and a bunch of other objects in the cluster, maybe in a bunch of namespaces. That's fine. We've talked about all of this. Now, you'll notice that the source and the apply object, they're describing, the, say in this example, the Git repository and then a customized build, right? And it's going to apply that to the cluster. Now, doesn't necessarily mean like when we're collaborating with our team that the same people who manage sources are also the same people who manage the way that configuration is applied to the cluster, right? Or maybe you just want to be organized a little bit differently. And so if the applier resource is potentially in a different namespace than the source resource, now you want to start referencing these things across namespaces. Other objects that do this in Kubernetes are cluster role binding. Cluster role binding can reference namespaces or service accounts in different namespaces. Also, if you look at ingress controllers, this pattern is inspired by Contour. Contour has a technique called HTTP route inclusion. It used to be called ingress route delegation. It's a way of specifying and enforcing policies across namespaces and referencing objects across namespaces. And so if you give a controller the ability to do that, then when someone says in their apply resource, oh, I want to use a Git repo from some namespace, how do you know that the person who made that apply resource and then the context of that source code actually, that those things have access to each other? And if you look at some of the things that are happening in multi-cluster networking right now, something that's people are starting to reach for is ACLs. The thing that I want to encourage here, this is a simpler version of that previous picture where the source and the apply are in different namespaces and they're referencing each other, is to say on the source resource, which is being referenced from outside of the namespace, maybe we can put an access control list, right? So maybe when the controller is, the apply controller is looking through, it can go in and look in the source object and see, am I allowed to actually access that thing? This is a really simple way to implement this. It's a little bit problematic from a permissions and policy perspective, but very easy to work with, super good UX. You know, the person authoring the source object can just be like, hey, I don't want this thing to be used outside of these namespaces. You know, just list it. Problem is that needs to be obeyed by the client that's actually reading the source object. By that point, you've already looked at all the fields. And so the way that I want to encourage that this is done is the very basic thing is that we keep using user impersonation, right? If we know that the apply controller is going to drop privileges to an impersonated user, then we can actually create role bindings in the repository management namespace that give access to other namespaces. Some folks maybe don't know that that's how RBAC can be used, but if you want to give access to somebody in a different namespace, you role bind to that service account across namespaces just using normal Kubernetes. And this is really good, and if you want to then implement the ACLs this way, you can give source controller, right? The thing that manages the source object, the ability to create a role binding on behalf of that access control list. That will open up that access for you with a really simple UX. And the reason why, even though this may seem a little bit more complicated, it's, in my opinion, the best thing to do, is you're using the API server as the policy engine, right? You're using it as the authorizer for this access control list. So we only write our controllers, we drop our privileges when we need to. And then if we want to implement an ACL, we actually go and make that role binding, and now the authorizer is outside of any of the code that we've written. That means that if the apply controller in another namespace wants to access a source in a namespace that it doesn't have access to, the issue that it's going to get when it tries to get that source is from the API server saying you don't have access to that. And this has another benefit, which is that now if you do it this way, because remember, GitOps is about people collaborating with each other with our tools. It's not about stuff that's happening inside a cluster configuration. We make these multi-tenant APIs so that people can work together effectively. So people can know each other's identities, so that people can have access to repositories that are only affecting the things that they need. And so then there's all these usability issues of like, you know, you're in kubectl doing kubectl auth can I, you're trying to figure out what does this person have access to? Well, you can build higher level tools on this primitive because the command line libraries can see, oh, do you have access to that thing? And you don't actually have to get the object because it's just RBAC. I'll show you. Here. This is just too much explaining. Let's just demo it. kubectl auth. Can I get, you know, service and, you know, or let's just even just get list. Right, so it's like all of the information about what this very restricted service count can do, right? You can see that you have a create verbs, or no, sorry, this is the admin service account. I can create anything, right? I can do the discovery APIs, and then I can hit all of these endpoints here. Right, so there's a bunch of health endpoints in Kubernetes. And then if I drop privileges, then I can only, I lose the star access there. And so if what you can access is always available, right, it tells you the Kubernetes API server tells you what you have and don't have access to. You don't need to do anything insecure in order to figure out what your access control list is. You can literally just ask kubectl auth, can I? There is a flag here, all namespaces, where you can run that on a particular resource or API group and then get the full list of what Git repositories you have access to or that sort of thing. And that can, again, be applicable to whenever you're building a complex API and you have these multi-tenant needs. And so in kind of conclusion, this is the link to the proposal. Go ahead and just check that out. Oh, I didn't mean to click that. There we go. The whole kind of point of what I'm getting at here is that I think right now, Open Policy Agent, Kverno, it's getting super popular. We're like, oh, I want to make a bunch of ingresses, and I want to build like external DNS, and I want to use all of these monitoring APIs, and I'm struggling. My developers, they can't even log into the cluster, right? There's no like identity, right? I'm just trying to bolt all of these things together to build a platform on Kubernetes. I'm trying to do the platform building platform thing. And it's because we're reaching for these policy agents. We're starting to write these things. We're using a mutating policy admission controller in between the requests to every single thing to the API server because we cannot trust our extensions. Right? Our extensions have complicated APIs, but they don't have an understanding of how to drop privileges when we want to give access to the people that need to do the thing with the extension. And if you want to look at this proposal and kind of get a better idea of how you can use user impersonation to drop privileges and how you can then use it as a primitive to build access control lists with your multi-object APIs, even across namespaces, which is something that traditionally extensions really suck at, then we can build better tools. We can collaborate with each other, and it's just gonna be like a less sucky time. I mean, this is just miserable, Come talk to me. I'd love to hear your thoughts about this, especially if you were able to connect or learn something from the presentation, let me know. And hit me up on Twitter and GitHub. Cheers.
Yep, I think we don't have time for questions, but you can grab Lee in the hallway track, and I'm sure he'll be happy to talk. So yeah, thanks.
Catalonia's Notice State. Catalonia's Notice State.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's Notice State. Catalonia's Notice State.
Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia had the beginning of the United Nations.
Catalonia's Notice State. Catalonia's Notice State.
All the authorities of Catalonia in the 11th century met in the city of France, at that time Catalonia, to speak about peace. The 11th century, peace in the world, and against wars.
Catalonia's Notice State.
Yeah, I mean, feel free
All right.
to say it.
So for the last talk before the lunch break, which I'm looking forward to, we have here Francisco and Rajula, sorry, who will be crashing clusters until they are ready for production, I guess. So yeah, very excited to hear you about it.
Thank you. Hi, everyone. This is my colleague Francisco, and I'm Rajula. We are junior engineers from CERN. Today we're going to talk about our story, how we crashed our way into production. So before I start, a quick introduction about CERN. As you all know, we are the largest physics laboratory. We primarily deal with research on subatomic particles and questions like how is the universe born, dark matter, and stuff. And this is also a place where the internet was born. And we don't just do physics, we do a lot more than that. So at CERN, everything is service-based. So the bit interaction is like we are a community of more than 18,000 people with around 12,000 plus scientists from around 110 nationalities. So we are a huge community. So it's obvious that everything is like a service. Like say, the grass outside my office window is lot. You want to get it trimmed, we just create a service ticket. So it's like that, everything is a service. And the same with IT. So every IT service is provided as a service with a different team. So we primarily deal with websites, like all the public-facing websites. So we have around 1,500 plus websites. So like, for example, the homepage, the home.cern, the most visited page on our infrastructure, or the careers.cern, or visits.cern. Just a bit advertisement, the visits are open at CERN. You can also book a visit on the website. So I'm going to give it to my colleague to talk about our story.
Okay, so starting our story, I'm going to start with our team. As my colleague said, we are the content management systems infrastructure, so we're mostly responsible for the websites. And in this case, I'm going to make the story more in a funny way. So our story is for Amigos, which are responsible for this CMS service. And they have at hand a physical infrastructure, so an old way of deploying websites. And their mission is to go into the clouds. So first, they create a plan. So we designed and built our own operators, and we also integrated them with external services. As we can see here, we integrated with authorization, with the CFFS service, database, etc. So the team starts climbing the stairs to clouds. But they get blocked. They get blocked by a creature. And this creature is called Ceph. So what happened with Ceph? With Ceph, the Ceph services started noticing that we were creating a lot of load on their service, and they were complaining, but we were not aware of that. So they give us these fancy plots showing that we are creating a lot of requests every 10 minutes that is affecting their service. So after a lot of conversation and a request from them to try to do everything so we don't shut their service down, we noticed that in our service we have a few pods that are in infinite rollouts and another few ones that are in crash loop backups. So as soon as we stopped those, we can see that the loads disappeared. So now we already have, let's say, an idea of what can be wrong. So after a little bit more of investigation with the CFFS team, we noticed that the CoreOS kernel, when we are mounting persistent volumes into a node, the node is relabeling all files. So if we have big persistent volumes, we're going through a lot of files and relabeling them all. So this was, in fact, what was creating this huge workload. So how did we handle the monster? We created a merge request upstream as well with an issue to explain what was the problem and then fix the solution. So now that our first block is out of the way, we continue our climb into the clouds. And now we get frozen by the kernel.
Yeah, so we're now blocked by the new monster with kernel freezes. So all of a sudden, our worker nodes have kernel freezes, and they go into a not ready state. So we don't have downtime, but it was still affecting us because a lot of nodes were being restarted and recycled. So after a bit of investigation, as usual, we started wondering what was the problem. So we spoke to other services, like the OpenStack team, the network team, and all. But we couldn't find any clue from them. So after a bit more investigation, we started seeing something upstream. So we started seeing that in the latest version of OKD that shipped with the kernel, specific kernel version, had a bug. So the Fedora OS kernel has a bug which was causing the nodes to restart. And this was not visible in every cluster, and it depended on the workload. So we could see it on our clusters because of our workload. And then we figured out that we could, from a comment from the same issues, that by downgrading to a specific minor version, the problem could be fixed until the OKD ships with the fixed kernel version. And we were able to actually fix it, mitigate it by changing the kernel version. Just to note that, it's so cool that even though it's not downtime, but through a discussion with some strangers talking about solutions that could help us fix an issue that we've been struggling for days. So we start continuing our journey. And all of a sudden, the stairs are going down faster than actually going up. And we start wondering, are we actually going slow? So we started getting multiple requests, reports saying that we have degraded performance on all our websites and all the infrastructure. So we start wondering, as usual, we start seeing what is the issue. We give more resources, we give more replicas, we start optimizing the infrastructure as much as we can. And we check with database team, network team, and storage team. And they all confirmed, yes, it's all fine from our side. But after a while, we started using more debugging tools. And then we figured out we had an imposter. So the database service that was providing us was degraded. And there was a bottleneck, which even they didn't know. So yeah, after a bit more investigation, after talking to the other database teams, they moved us to a specific infrastructure where the bottleneck was reduced and we had good performance like we wanted. And we start continuing our journey. We almost close. And now we lost the backup ropes. So Velero is a very major component in our infrastructure where we want to take backups through Velero, and we want to take stateful backups through Restic. So because we have more than 1,500 websites, we wanted to take backup of every website once a day. So we have 1,500 plus backups created through schedules. And each backup took 5 minutes because of the number of files on the PVC. And you can do a simple calculation. We can only do like around 300 backups per day. So because of this, we started having a huge amount of backlog. And if you are aware, Velero Restic controller processes only one custom resource at a time. It doesn't do parallel, it's sequential. And then we try to mitigate it. We maybe reduce the backup to once every 2 days. So we have only a few every day. And then we start seeing more issues upstream. We were discussing and want to contribute or do whatever we can to get this fixed. While we were also waiting from our CephFS team, where they could provide CephFS snapshots on the PVC, where you don't have to use Velero. And before we could actually fix the problem disappears. So we found that we had a bug in our database script, in our backup script, which reduced the amount of time taken for a backup from 5 minutes to less than a minute. And overnight, all our backlog disappeared. So the next day morning, we could create on-demand backups. And then we had to investigate to understand why the backup log disappeared. But we still plan to get this feature, which helps us and also everyone in the community. And I give it to my colleague.
Yeah, so by now, and after all these crashings along the way, we finally reach the clouds. But the process is not over yet. So looking back, we started on physical machines. We prepared our way into the cloud, so we created all the components necessary to provision it in the cloud, such as the integrations with the other components and the other services. Then we moved into the cloud, which is where we are at now. But now we still need to better monitor our resources, our workload, and we still need to do some continuous improvements in the current infrastructure to make it better performant, etc. So by now, we can ask ourselves, what did the travelers learn? So the travelers learned quite a few things, starting with the collaboration. So with the collaboration with upstream and also with our colleagues, we were able to tackle a lot of these problems. And these problems are beneficial not only for us, but they are also beneficial to the community. So some of the things that we found can now be used as well from the other colleagues on the community. A second problem is that some issues are inevitable. So even if we had everything planned, even if everything in our site worked correctly as we initially thought it would, then we still have issues that are out of our control that continue to happen. So we made a few proof of concepts. We didn't went to the point of having work-like workloads, but still things fail because of Linux, kernel bugs, etc. As a third point, going too fast. As a third point, no CNCF project is robust out of the box by itself to every use case. Sometimes it's required to have some patience, some energy, and some contributions, like we did, to make it work. And finally, it's important to be mindful about dependencies. So in our case, we had some issues with our service because we were not fully aware of the extent of the dependencies and how they could affect us negatively, our service. So by now, I would like to thank you all for this presentation about our way into production, and I will open now for questions about our service and our experience on going to the cloud.
Any questions?
Sorry, I might have missed this in the first part, but you talked about front-end web applications running as part of this infrastructure, is that correct? Mm-hmm. And any experience from the services access themselves, the connectivity, any sort of best practices?
Sorry.
In terms of just the networking, getting the services spread across your infrastructure, because you're doing this at scale. Any sort of learnings from how you do load balancing, how you do service discovery, did all of that work reasonably well on Kubernetes?
So from the Kubernetes side, there's a few things that we can say is that, for example, we noticed that monitoring is easier to be done in the Kubernetes. And also there's a lot of ways of working on upstream, such as, for example, the canary deployments, etc., that also can be easier to be done in the new infrastructure, the Kubernetes, versus the old one that we had in physical machines.
What do you use for canary deployments, by the way?
Sorry, it's a little bit too, I'm a little bit deaf. Could you speak louder?
What do you use for canary deployments? How do you do canaries?
So currently we don't do canaries. What we do is that, and maybe I can roll back in order to explain you a little bit better. So by the way, we did a presentation in the last KubeCon about the infrastructure, let's say, architecture. So back then we still were not in the cloud. But basically here what happens is that we have this thing called Drupal site, which is a custom resource we built. And we also have an operator that reads this custom resource and creates the necessary deployments. And what this custom resource also has is a specification on the version. So what we can do is we can roll out the new version for just specific websites, and we try to avoid the critical websites first and deploy first these specific versions on test versions, on our internal versions to validate the version is stable. And once we have that, we deploy it to the production. And then it's just a normal Kubernetes deployment where the new pod is rolled out. And we currently don't have, let's say, a way to, let's say, have two pods working at the same time, some still redirecting to the old version and some to the new for some dependencies. For example, the CMS, we don't know for sure how how it can support two database connections from different instances, etc. And we are two junior infrastructure developers, so we still have some things to figure out to make more and use more about the Kubernetes. Like we said, now we are in the cloud, but there's still some things that we can improve. So that's definitely one of those.
And one follow-up question on that. For example, I see an authorization operator, right? Mm-hmm. So if you have an external integration to an OIDC provider or something, but are you passing around things like JOTs?
We have another component that actually was built in-house, which is the authorization component, and it's also the same logic. So it has a custom resource. We have at CERN our own authorization system. So basically this authorization operator creates a custom resource, so it creates an authentication with our OpenID, and then we use these OpenID credentials and inject them into the Drupal site deployment. So on every, let's say, new project that is created, the authorization operator also has a custom resource, which you can see here, which is called authorization registration. And then after our Drupal site operator gets the secrets of the OpenID credentials from the authorization registration, and then injects it into the Drupal site OpenID Connect module, which then makes the bridge with our authorization service. And this is just one of the examples of the
Exactly. So if you're doing authorization at the application, you don't have to worry, I'm assuming you're not worrying about things like network policies or the Kubernetes level sort of.
So in our case, it's mostly self-managed. We do basically software as a service, and we provide the Drupal side of the box. We don't give, by default, permissions for users to create pods, deployments over workload overall. So definitely, we also are not deploying this on Kubernetes, but OpenShift, which also has some more separation between projects, which also helps us with the security and separation between websites.
I think one other thing I could add is I think we have a graph for. Yeah, so some websites have a huge amount of load. Sometimes you have like 30,000 unique visitors per day. And with Kubernetes, it made really easy for us to scale specific services. Like usually in the old stuff, if you want to scale a website, we had to scale the whole infrastructure itself. Now we have granular resource management that we could do. Like say the home.CERN receives a huge amount of load when there's a new article, say about a new experiment that actually had some success. So it actually helped us in that way.
Yeah, and it's actually funny because we can tell whenever they make new fancy articles by the workload in the deployments.
More questions? All right, then, yeah, thank you very much, Francisco, Rajula.
Yep. Yeah, thank you.
So we have a lunch break now, and we'll be back with talks at 3 p.m. So, yeah, looking forward to seeing you all.
I need you. I need
It's sexy.
didn't know. I didn't think to find a way to have some peace of mind. But you make me come alive. You lock me up inside. Yeah, you make me wanna move. Yeah, you put me in a mood. And all you gotta do, yeah, all you gotta do, yeah, you make me wanna yeah, you put me in a and all you gotta yeah, all you gotta I don't know it's me you see for the shine of my reflection. The meaning of your being is you can't resist my nectar. Go, 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 go. Bring it up a notch, 'cause I'm making an entrance. You say don't have enough, you gotta play it up. But if you want a reason, take the my full lessons. Better have patience, 'cause I'm gonna take my time. One in a million, 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 one in a million.
Coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz. Coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz. essa vida de aprendiz.
minute, don't know. Get a minute of your time. Get a minute of your. First you gotta live right, and I'm never gonna let you out of my side. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. Part of the creation, the relations I've got, the only one that keeps me safe, the only one you should trust. For sure, it ain't right that I have checked the speck of dust from all of its side. Fall down, not from my height, cause I didn't see the plank I had in my eye. You hear yourself when no one's to be found. What keeps you eased out? What takes you off your mind? Yes, you want this, I want this. Everybody in this, you should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass, and happily perform the new in your hands. I sure gotta live right, and I'm never gonna let you out of my side. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. Part of the creation, the relations I've got, the only one that keeps me safe, the only one you should trust. Yeah, you better. For sure, it ain't right that I have checked the speck of dust from all of its sides. Fall down, not from my height, cause I didn't see the plague I have in my eye. You hear yourself when no one's to be found. What keeps you eased out? What takes you off your mind? Yeah, you better. Cause you want this, I want this. Everybody in this, you should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Yeah, you better. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass, and happily perform the new in your hands. Yeah, you better. Yeah, you better. Cause you want this, I want this. Everybody in this, what should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Yeah, you better. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, I'm the mass, and happily perform the new in your hands.
Catalonia's Notice Page. Catalonia's Notice Page.
But let me say one thing. I am a Catalan. Today, a province of Spain. But what has been Catalonia?
Catalonia's Notice Page. Catalonia's Notice Page.
Catalonia has been the greatest nation in the world. I will tell you why. Catalonia has had the first parliament much before England. Catalonia had the beginning of the United Nations.
Catalonia's Notice Page.
All the authorities of Catalonia in the 11th century met in the city of France, at that time Catalonia, to speak about peace. The 11th century, peace in the world, and against wars.
Catalonia's multi-tenant. Catalonia's multi-tenant.
I need you. I need
Hello. Again, the first speaker today will be, after the break, will be Marino. He will be talking about networking engineer goes DevOps. So let's start.
All right, thank you, everyone. Who here, raise your hand, by the way, who here has left their talk to the last minute, figuring out their slides? All right, great. Take that hand, pat yourself on the back. So my talk is on like network engineering and how it kind of moved towards a DevOps movement. But I'm going to make like a very interesting statement here. So, you know, having been in network engineering for 14 years and then looking at something like service mesh, to me, service mesh is just basically a VPN at this point. But the reason why I say that is because a lot of the technologies that I've seen over the last 14 years have effectively gone full circle. And so let me go ahead and introduce myself. My name is Marino Wijay. I am a Canadian, so I flew all the way out here to see y'all and hang out with the KubeCon crew and whatnot. I am a developer advocate at Solo, which focuses on application networking, so things like API gateways and service meshes. I've been in the tech industry for probably about 18 years now, but spent the majority of that doing network engineering and variations of it. But part of the reason why I'm giving this talk today is because I noticed that we were leaving behind the network engineers as we progressed forward with microservices and containers and the whole Kubernetes movement. And so I'm here for the network engineers, the ones that literally want to transform their careers and take their network engineering skills and go DevOpsy. So my journey started off like when I went to a computer store and decided to buy a wireless router, like one of those 802.11b routers with a wireless adapter and whatnot, because I wanted to get internet in my room. And when people started to see me do these kinds of things, they called me up and were like, hey, can you set up something very similar for me at home? And I'm like, sure, I'll charge you however much you want me to charge you, and we'll get going. And I started to realize how much I truly enjoyed networking altogether, just seeing like packets flow and move around. But I realized like setting up wireless networks wasn't just it. And so I want you to for 1 second, just imagine an OSI model. Actually, I won't do that to you. I'll actually show you an OSI model. So the OSI model, I kind of started at the very bottom there where you see the physical layer. But what I tried to call out here is that there are a lot of vendors, a lot of technologies that kind of flowed through this OSI model from layers 1 all the way up to layer 7. And my journey, as I started in layer 1, as I moved up that stack to focus a little bit more on layer 4 and came to layer 7, I started to see, oh my gosh, these patterns are the exact same. And so let's talk a little bit more about that and what that actually looked like. So I had to start my journey to learn like networking, and the best way to start it was to actually go the certification route. It was like 2008, and I was sitting in a network closet configuring a bunch of Dell switches, plugging things in, not really understanding if things were working, but I plugged and prayed to see if things would move around. And the person I was working with at the time, they were remote, but they hopped on the phone with me. They were reviewing configs, and I'm like, hey, how did you figure out all of this stuff? And they went like, hey, I'm a civil engineer, I build roads, and I love to know what's going on those roads. But I started by chasing after a certification to better understand, how these little devices connect to each other, how I plug in a console cable and configure like a router or something like that. And so what I ended up doing was chasing that certification dragon for probably a good 5 to 6 years. So I progressed through a well-known vendor's certification track. And then I got to a point where I realized, like, oh shit, this is actually not for me anymore. Like, I did not want to put myself or subject myself to that level of torture of going all the way to somewhere like RTP in North Carolina to write an exam where you're literally in a lab environment for like 8 hours straight. That just wasn't me anymore. And so as I kind of moved beyond that, I started to focus a little bit more on the data center and the storage elements of the data center networks. So what that meant was like I was dealing with storage area networks, fiber channel, iSCSI, and all that fun stuff. But I saw this pattern. I'm like, okay, this is the exact same pattern that you would see in a networking environment, except I'm just moving a bunch of different kinds of packets all together. And so I spent time building out SAN environments, learning and perfecting my knowledge in something called fiber channel over Ethernet, only to realize that it would become deprecated and not used like few years later on. And so when I think about that, I had to transform as an individual, but I wasn't really sure how I was going to go about doing it. I was confused. I thought I had reached the pinnacle of my network engineering career, and then I realized, oh my gosh, there is just so much crap that I have to deal with as a network engineer. I just simply can't do it. Like, imagine, in networking, you have to configure devices. You have to configure routers, you have to configure switches, you have to tell them what they need to do and what packets to move around. But try doing that for 1,000 different devices, only to realize that you have thousands of different configurations and you have to manage them all. And if you have an error in any one of them, you might be spending a lot of time trying to figure out what's going on. Going back to the storage networking realms, there was a concept called zone merges that you would do with fiber channel switches, where you would merge multiple virtual fabrics together so that you could have this host access a disk, and that disk is known as a LUN through something called a worldwide networking name. Now, if you mess something up, your zoning was way off, your LUNs would not map to your hosts, and guess what? Your virtual machines would never power on. It was just misconfiguration. And so I started to think, like, why did we ever not have Git back then? Like, where was Git when I was struggling to maintain like 5 different config files on 20 different laptops to be able to at least come out of that network strong? But it's here today. Like, Git is there today, and people are using it actively. But what's more important is the element of these patterns of, like, you're creating something, you're having to iterate on a configuration, you're having to make changes, you're having to manage the lifecycle of that configuration. And this is no different than what developers do. Like, I'll create some small application, I'll upload it or I'll push it to Git, and then someone else can access it and make changes, collaborate, etc. But what about network engineers? We needed to do that too. And so, as networking kind of evolved, we got smart. and we started to automate a lot of things. We would automate the network, we would automate VLANs, we would automate as much routing as we possibly could, but we also needed a framework in which we can operate out of. And so that framework actually happened to be things like Python. There were Python libraries developed for us to be able to effectively configure our networking devices, right? In fact, like a lot of the vendors out there started publishing APIs that you can interact with. They were based off of like netconf and restconf, and even like the Open Daylight controller. But effectively, these were the underpinnings of something called software-defined networking. Except we were just automating things. We were creating scripts. We were creating Python scripts that we would just push to our management layer that would go out to configure devices. And we weren't having to plug in a console cable anymore. So that was effectively net DevOps. There was a new system that came out too called Napalm, which is effectively a multi-vendor system or platform where you could deploy your whatever configurations you want, and it could push to as many devices, different types of devices. So that was like some serious true network automation. Now, once we got past that, like we started seeing another movement. And this was this whole movement around software-defined networking, where I'm like building virtual networks on top of physical networks. And these virtual networks were like, they could be spun up and destroyed as quickly and as efficiently as you wanted to. But the challenge with that is that you now had like so many other things to worry about. You had to worry about if you had enough overhead on your switches to support something like an overlay protocol or an overlay mechanism like VXLAN for that matter. But the whole reason we moved to this whole space was because the cloud movement and what they were doing in the cloud. They were creating these virtual networks anyways. And in the physical world, in data centers, in closets, we needed to do the exact same thing. And so software-defined networking really changed that paradigm altogether. It allowed us to move beyond like the physical devices, move beyond boundaries that we never thought we could before, because at this point, I just need IP connectivity and I got my own networks wherever I want them to be. And then I come to find that we also started virtualizing the WAN as well. How many of you have played with IPsec before? Right? So you probably sat there configuring 2 PICs or ASA devices or 2 firewalls to create that tunnel. Someone probably fat-fingered a passphrase or something like that, or a certificate, and then the tunnel never comes up, right? So, we realized how much of a problem that was, and we tried our best to automate that. We did with Python, but we took it another level, and we decided to give you a UI, or UIs, or APIs where you can configure all of these WAN networks in IPsec without ever having to worry about touching a config file at all. And so SD-WAN actually took the industry by storm, only to realize that it was just a necessary part of the puzzle, and it would become so downplayed that no one really cared about it anymore. And so as I was starting to see this, I started to get bored of network engineering. Like things were just like so automated. There was no excitement in what we were doing. BGP kind of did its own thing, and it was always going to be around. So what now? What next? And that's how we arrived at something called Kubernetes. So Kubernetes, was launched 7 years ago now? 8 years ago? 2016? Yeah, so 6 years ago. Is my math right? Yeah, it's right, okay. So at that time, like there was a lot of magic behind it. Like we honestly didn't know what we were doing, what we were working with. But in fact, what it really came down to was we were working in the Linux kernel, creating networking namespaces for that isolation. We were basically messing around with the kernel so that we could run IP tables to be able to basically use something called NAT to basically give us more life in the IPv4 world, which I'm not going to talk about right now. That's another story. But I realized that Kubernetes itself actually created a paradigm shift in which we were doing networking. Like we actually did not give a shit anymore about that physical network. As long as it was there, I can build my Kubernetes control plane and my data plane, and then I can deploy any kind of network I wanted to. And that's when that true DevOps or net DevOps movement started happening, because now everything started moving over to microservices, containers. Like how do I make sure that container A is communicating with container B? But oh, by the way, container A can die at any time and come back to life in a totally different form. and I change my IP. So what the hell? Like, what am I doing? So one of the really interesting concepts that I saw in Kubernetes to address the networking was labels. Like, labels is a very, very powerful mechanism to be able to mark traffic, route traffic, be able to determine if traffic from, like, let's say namespace A can communicate with namespace B or something along those lines. And that was a very cool damn movement, because now you can basically take your networking stack and just shove it in YAML. But I'm not going to show you any YAML today, sorry. The other thing that I also noticed is that the same challenges we had in the physical world, in the non-container world, existed in the container world. Like, if your DNS was off, guess what? You're never going to be able to, nothing can communicate. If your time was off, like the network time protocol was off, guess what? Things are out of sync, right? If your MTU was off, things can't communicate, things can't fit through that road anymore. And now things will be half broken in terms of communication. And so this is networking all over again. Literally, we are looking at networking technologies that are the underpinnings of our physical network, of our Kubernetes network, of our virtual networks. So again, another intentionally slide that's blank, but the idea is that now in Kubernetes, I have what we call a container networking interface, right? That's our, I would say, our switching layer or our layer 2 layer. And that's where we're able to create a data plane where, you know, containers can talk effectively, and we could do some really interesting routing. But then, what if we want to get very creative at layer 7? And so we started to see how API gateways took storm. You know, we're becoming very Kubernetes native, would create these ideas of upstreams for all these different services that you would need to route to, and you would have this like front door firewall, effectively, that just sat at the front of your Kubernetes cluster and just accepted traffic based off of a variety of different conditions. But we needed more. Like, literally, if I had one single point of failure, that's not enough for me. That's not what I want. That's not how we want to approach things. And so we kind of arrived at something called service mesh. So service mesh, for those that aren't aware, is pretty much a technology that sits at layer 7 that allows us to do some very interesting traffic engineering. It allows us to inject security, and it allows us to just see observability patterns. It's a layer on top of Kubernetes. But these 3 key things that I just said were things that were pretty much in like any kind of VPN setup that you would do. So in the security realms with respect to a service mesh, you're using something called MTLS, or mutual TLS. And that's just effectively creating a secure tunnel between 2 endpoints, which is no different than creating a VPN tunnel between 2 endpoints. So, you know, it kind of goes along with what I said earlier. Service mesh is just a VPN, but it's actually more. I also started to notice that, you know, the command that I have on there, istio proxy config, or what is it called, istio proxy config route, is basically outputting a routing table. If you are a network engineer and you do a show IP route, it is outputting a routing table. Same concept. And so the patterns are effectively the same. Like, there's nothing that has changed. We have just basically cosmetically changed how we approached things. We've automated things. We've made things a little bit easier, more consumable. But then we started putting networking in every single YAML. Now, I have an interesting story about this. So about 3 weeks ago, I went out to, 3 weeks ago, I went out to Raleigh to just attend a DevOps days. And it just so happened that the DoD was there, Department of Defense, and we got into talking about some things. And then they introduced me to someone that wasn't part of the DoD, and I just got into a conversation with them about like just the patterns of networking in Kubernetes. And they're like, let me just tell you what I've been doing in Kubernetes. I'm using Kubernetes with something called KubeVirt, with the Multi-CNI, with the Cisco CSR 1000V. And I'm like, what are you doing with all of that? I've effectively created a network edge for my needs. And I sat there and I thought about that for a minute. And I asked him, did you deploy all of that in YAML? Yes, absolutely. And so when you think about the networking side of things, especially when it comes to Kubernetes, all of that now can be easily defined in YAML. I can create routing configs, I can create access policies, I can create pretty much anything I want, like a pool of IPs for my containers to consume. And that's what's really interesting, because guess what? 12 years ago, I was doing all of the exact same things, just in a spreadsheet, in an Excel spreadsheet, unfortunately, because we did not have all those tools, right? So, fast forward to all the way to today. We're DevOps, we have Kubernetes, we have this massive cloud-native ecosystem, and we have Service Mesh, which is providing us all these capabilities. But if you look up there, Service Mesh is a router, Service Mesh is a VPN. Is Service Mesh a system for PRTG or MRTG? Technically it is, because it's offering those observability points. In fact, what we did with Service Mesh, and specifically let's talk about the Istio Service Mesh, because I'm most familiar with that. We took the Envoy proxy, a highly functional layer 4, layer 7 router, and just layered abstraction on top of that. We put that router right beside a container. What did we do? We effectively just re-engineered everything. We went network engineering hard mode, and we decided we're going to put routers everywhere, except I have a control plane that's able to push configs to wherever I want, whenever I want, so this is easy to manage. And that's how we got here. We got to this point where we're realizing we need to bring routing closest to the source, but we also need these very interesting ways to create traffic patterns for our needs, because guess what? Our microservices are evolving. I want to be able to do CI/CD with them, and I want to be able to do blue-greens and canaries and all of that fun stuff without ever impacting production. But how we were able to do it 12 years ago is the exact same way we're doing it today, except we're using cloud-native technologies. So the moral of this story is that for the network engineers that have basically sat there thinking, where do I fit into this whole DevOps movement? Service Mesh, CNIs, API gateways, Kubernetes even for that matter, because it's so networking heavy and focused, is where you want to go next. Because that's where I went. And I ended up doing that by following the packet. And what I mean by following the packet, I'm literally using Wireshark and oh my gosh, TCP dump in Linux to really figure out where things are moving, who's talking to who, because at the end of the day, that is what network engineering is. We want to see the packets. We want to follow them end to end. So, to the network engineers out there, you have a place out here. You are welcome. If you are out here today, you are welcome to come talk to me, and I'll tell you a little bit more about that journey. I'll tell you how now I basically configure all my networking in YAML, because I don't have to worry about managing multiple configs. I've got a system that's so clean. It's Kubernetes, and it's taking care of a lot of different things for me. So that being said, I want to thank you all for attending. I intentionally wanted to be short on this talk because I know how we all love breaks and how I don't like talking that much. But I want to thank you all. I want to thank you for your attention. I want to thank you for joining my talk on Network Engineering Goes DevOopsy. Service Mesh is just a VPN, but it's also so many things more than just that. Thank you, everyone. Are there any questions while I still have, I guess, 7 more minutes?
Yep. Do we have questions?
Good. All right. Oh, all right. Let's go.
So you think that all service meshes can be broken down into routers using the Envoy proxy? Is that the conclusion?
That is one way to look at it. The nice thing about the Envoy proxy is how versatile it has been made so that we can manipulate it to pretty much anything. So a lot of the service mesh providers out there, like Istio, for example, and even to a degree Kong and its Kuma mesh use, if I'm not mistaken, they also use the Envoy proxy too, right? Or someone is using the Envoy proxy out there. But the idea behind that is when you're taking something that's so small and so tunable, and you could stick it anywhere, like pretty much as a container, and you can even create routing patterns, it is effectively a router at that point, right? But the key word in there is the proxy. So if 10 years ago you told me you want a proxy, right, that is more than likely going to translate to some sort of edge device that is routing, that is proxying connections, that is running NAT, that is receiving connections and then blocking others. But that's effectively what we're doing. We've taken that same idea, that approach, and just stuck it as a sidecar to run alongside that main container in your pod in Kubernetes.
Okay, I get that. But for example, there are some industrial analysts are pushing people away from service meshes. They are saying that you're going to complicate your environment, that you still don't have the skills to start with service meshes.
Yeah, and that's an interesting phenomenon that's going on because it all comes down to need. It comes down to what you're doing with your service mesh. Now, in a lot of cases, in a lot of environments that I've encountered, the patterns for which they're using service mesh might not always mean traffic engineering or MTLS. Or even like that security. What they might be looking for is observability. Like, what is going on with my application? How is it performing? What kind of latency is basically being attached to that application that is actually causing more of a delay downstream for other apps and causing maybe an outage or a lack of response. But these details aren't present in the physical network. They aren't present at layer 4, but they are at layer 7. These details tell us things like special attributes that we can also take advantage of if we wanted to take it to another level and start routing or traffic engineering with the information we know about. From a non-traffic engineering standpoint, let's just talk about security for a second. So you want a VPN. Where's my slides? That is a VPN, right? So you want a VPN, well, service mesh is your answer. If that's all you're using it for, if you're just securing traffic between endpoints, then it can be viewed as such. Now, there's going to be an argument for, okay, why can't I just do this in the kernel and not have to, inject sidecar? Well, the one thing to consider is there is a tax. There's always going to be a tax. Who's getting taxed is the question. Whether you're going to tax the hardware even more or you're going to tax the systems in which you run on top of in software. And so it's going to be an endless debate as to whether or not you need a service mesh and if you could do other things elsewhere, like in the kernel, or maybe, let's say, we want to do this in eBPF and avoid using sidecars altogether. But then it also means that you compromise features, right? If you want performance, you're going to give up something else. If you want features, you're going to give up performance. So it's an endless debate. I understand like where you're coming from, and I know where you're going with this, but at the end of the day, it comes down to use cases. What are you after? What are you trying to use? Do you need performance or do you need features? And maybe there's a bit of both that you could do too if you wanted to.
Thank you. It's a very comprehensive answer. One more question, if you don't mind. So basically, your talk was for network engineers. For us, the non-network engineers, what's your advice that we can pick up these technologies?
You don't have to learn subnetting.
I mean, like service mesh. How can I start learning service mesh? And like
so
today, this morning, the KubeCon next generation stuff like that.
Yeah. So if you are a DevOps today and you want to learn some more of the network engineering that's going on, some of the best ways to learn about it is learn about what goes on in Kubernetes networking altogether. There is a Kubernetes networking SIG, or special interest group, that provides a lot of different, guidance as to what they're doing in the Kubernetes world in terms of networking and how they're enhancing it. There are also plenty of vendors out there that produce get-started guides for working with, let's say, a container networking interface, so Calico or Cilium, so you could go head to their websites and they'll tell you how to get started rather quickly. And if you want to do the same for service mesh, Istio's Getting Started has so much information to get you up and running as long as you have a cluster or a Kubernetes cluster. It'll get you up and running in a matter of minutes. And not only that, like there are so many YouTube videos out there that show you how to get started too. Shameless plug, I work for Solo. We offer workshops on Istio, Envoy, and just advanced capabilities of Istio altogether. So if that's something that interests you, if you want to learn more, come talk to me or just go to soloio.com, or not soloio.com, solo.io. All right. Thank you, everyone.
Thanks, Arino.
the next talk will start soon. We're gonna start very soon the next talk. Thank you for waiting. Hola.
Hello. Okay, for our next talk, we will have Mario Loriedo. He will talk about extending Kubernetes for dev profit. Start.
Thank you. So thank everyone for coming, for attending. So I'm gonna talk about development on for and on Kubernetes. So but more as using Kubernetes, extending the Kubernetes API for development purposes. And in particular, I'm going to talk about the Dev Workspace operator. It's a Kubernetes operator that extends Kubernetes with a new custom resource that we're going to see. My name is Mario Loriedo, and I work for Red Hat as a developer. I work at the developer tools for Red Hat, and I'm also the project lead for Eclipse-Che, that is a service that's provision development environment in the cloud. But first of all, just the name of my talk is taken from this article from a few years ago, Smashing the Stack for Fun and Profit. So I just wanted to acknowledge that. Great article, so great that I will frame it and put it on at home. So for the happiness of my wife, so it's it's there. So, but anyway, yeah, this is not about security at all. The article was. My talk is not about security, but more about using Kubernetes for development. First of all, let's introduce the inner loop. So the development loop that we're used to. So it's usually we call it inner loop, and the activities in the inner loop are, first of all, coding. Then when you're happy with what you've written, you're gonna build the application. And then when the build finished, you test it, and then you you start again until you're happy, and then you commit your code. And then at that point, there is what we call the outer loop. That is what happens after that. So today we're gonna talk about the inner loop. So what usually you do on your laptop. So you code your own laptop, you build, and then you test it. You may build, use external services, deploy on Kubernetes to test your application, but usually at least the coding part often happens on your laptop, if not all of the activities. So what about using Kubernetes instead of your laptop for all the activities? Everything is gonna run there. So and the reason for that, so why would we want to do that, first of all? The reason so there are 3 reasons at least we want to do that. First of all, it's because provisioning an environment, so configuring an environment on Kubernetes will be just a matter of applying some manifest. You won't have to install dependencies on your laptop, etc. So that will be fast. So that's the first thing. Second thing is it's repeatable. You have done it once, you are gonna commit and version your manifest, the definition of your development environment, and all your team will gonna benefit of it. It will be repeatable. Every new developer that will come to your team will just be able to use the manifest and will be ready and productive in a matter of minutes. And at the end, so the last benefit will be that it is scalable. So you will be able to scale more than your laptop is able to. So if you need more RAM, more memory, more CPU, you will be able to provision a more powerful node or pods. And something that it's hard to do with your laptop, you won't be able to augment memory and CPU easily and fast as you can with the cloud. So these are 3 reasons. That doesn't mean that we should replace your laptop with Kubernetes. There are a lot of use cases where coding on your laptop is more practical. But for fast development environment, for provisioning fast development environment, that's clearly a good option. So how would we do that? So what have we done? So these are like the resources that are currently on a Kubernetes cluster. So these resources doesn't help with cloning the source code. These resources doesn't help with building your application or with interpreting your Node.js applications and running it. You don't have instructions for building and for testing your application right away with these resources that are here. So what we have come with is we've come with a new customer source that is called the Dev Workspace, and a controller that comes with it that manage the resources of type Dev Workspace. And Dev Workspace this is an example of a simple Dev Workspace. It has, at the bottom, you can see that there is a template and a component, and this is mainly the core of a Dev Workspace. You have it's just a container, what you have here. But then you can extend that with source code, so you can have source code that will be injected automatically in the component. You can have commands for building, testing your application, debugging it. And basically, this is the Devfile specification. The Devfile specification, there was a talk this morning that we did about the Devfile, so I'm not going to talk more about it. But the Devfile is a file, a YAML file that you can version in with your source code that looks like that. So you can version that on your source code, and then that will use exactly the same API. You will be pretty straightforward to translate that in a Dev Workspace, so in a Kubernetes manifest. You will have to add some Kubernetes boilerplate, but beyond that is exactly the same API that is powerful. You can add commands, you can add events for pre-start. When you start your workspace, you can add actions that can automatically be done. And there is also a notion of parent, so there is some inheritance of Devfiles. So the Devfile API is powerful. And we take that same API and we use that API to build the Dev Workspace customer source. Now, I'm gonna run a demo of the Dev Workspace. And what I would like to do is that I would like to start from a really simple Dev Workspace and go step by step until I get Visual Studio Code running where I can git pull and push, and I can debug my application. And for that, I'm gonna actually use this microservices demo from Weaveworks, and I'm gonna. So the goal is to be able to set up an environment for this service here, the front end that I've forked here. So this is the source code. It's a Node.js application that actually depends on other microservices. So if you want to test it, you will need to run a database and another service that provides an API, REST API, so that your front end will be able to talk with that API and get the information from the database. So it's not really simple. It's not just an hello world. It's a little bit more than that. So to show that some different use cases more powerful than just an hello world. So first step, we just want to get a shell with some development tools and source code. So I have a cluster. I already have a cluster provisioned with the Dev Workspace operator installed. So I will switch to the terminal here. So I can see that because if I do a kubectl explain, I can see that I actually, there is some description of the Dev Workspace API. So the Dev Workspace is available here. So what I will do is that, let me open another shell here. I'm local on my laptop here, and I just want to monitor the pods that are created on my namespace, because it will help us to track what's happening on the underlying Kubernetes. So we'll do a kubectl get with the pods that are here. So it's watch. Okay, so I'm just watching. There is no pod here right now, and I'm gonna do the first thing that I would like to do is that I want to create this Dev Workspace. So I will just do an kubectl apply of that resource. So it's a Dev Workspace where we have a project that is pointing to this Git repository, and where we have a component that is this image here, that is a universal image that we usually use because it has all the tools, development tools and language tools. So it's pretty straightforward to start from that. Then if you want some tools more specific, you can customize that, but this is the default image that we use for the Dev Workspaces. All right, so let's just do kubectl apply of, I've numbered that, so the basic one. All right, so I've applied it, and you see that there are a pod that has been created. So there is an init phase. During the container init, the initialization, the first containers are run to clone the project. So that's why we're running. There are a couple of things that we do every time before starting a workspace. One of those is doing a git clone. So now it's running. So if I do a kubectl get dev workspaces. I see that, so the dev workspaces is running, and I also have a link here. So if I just copy that, and yeah, I will open another tab. And put thing here. All right, that makes it bigger. So I've got a shell. And let's try to do something. All right, let me make it less bigger, and let's continue with presenting here. All right, so I've created this dev workspace. So I've got a shell. So I have a shell. I have the source code as well. If I do ls, I see that I have microservices demo front end. If I can just, for example, I have VI here, so I can just open that folder with VI, and I can navigate the code. So I haven't installed anything here, so I'm just running something on Kubernetes that has cloned my project, that has provisioned a container, that has development tools. So we'll see that we have Git, but there is also VI, or you can add even Emacs if you prefer. But yeah, the point is that we have that. But for example, I may be interested. So a developer may be interested to start customizing this. So for example, the prompt here is not really, not really beautiful. So we can make it more beautiful. We can, for example, change some configuration file like the bash rc, and that's what I'm gonna do next. So second step is adding some configuration. So injecting some files, some dot files, for example, to make things more beautiful. So how we do that? We do that with just a config map with some annotations. So there are some annotations to say where actually the file will be mounted, how it will be mounted, and then there is the data that explained, like here is just a PS1. So it's just I want just to show the mechanism. I'm not putting complicated things, but you can put any file you want, and that will be, once you create that config map, when the workspace is restarted, that file will be injected in all the containers of your workspace. So going back here, I'm gonna run the second step, the one that will create the config map, and it will stop and restart the dev workspace. So we see here that is the pod has been terminated and it's restarted. So the dev workspace controller has refreshed our pod. All right, so here I can just press to connect. It's going to reconnect, and my PS1 now is a little bit nicer. Nothing fancy, but yeah, it just proved that that worked. So the other thing is that if I go in my folder here, so I'm in the source code folder, and if I just try to do git push, it asks me for my credential, right? I would like that not to happen, so I would like that to have my credential injected automatically. So how do we do that? We use secrets. So, and this is an example of a secret to inject Git credentials. So you can use secrets for injecting any credential in general. And this is, so still, again, it's using labels and annotations. The dev workspace operator will figure out that there is something that needs to be auto-mounted in the containers. So, okay, let's do that. Let's apply the secret. Again, so secret created. The dev workspace has been restarted, and here it tells me that it has been offline. So again, okay, it has reloaded. And if I do go in my microservices, I will be able, that was not working perfectly before, but you will see that, yeah, it's, I don't know why there is, it looks like there are two files that are mounted, so it doesn't get the permission to get the credential of one of the file, but then is able to get the credential and to connect to GitHub and to yeah, and to use my Git credential, so my username and my token to be able to connect to that. So we have injected the secret. So this is the Git credential. So but we haven't started coding or building yet, nothing at all. So we need to do that. So what I can do is that once I'm here, I can do a yarn install and yarn start to build and start my application. So that happens. So I need here to. So this is cool. So my application now is running. So I've been able to build the application. And what I will do is that I will open a second. So I will duplicate my tab, and I have a second shell now. And I can test. I can just, without, so what I will do in development, I can just do a curl to test if my application is responding correctly. So if I do a curl, so it says that it's listening on port 8079. Okay, so let's try that. So it's answering, so it provides me a response on the root. But then I want to get a list of items from the catalog. So that's through this path here. And if I try to do that, it actually is not able to connect to the catalog because I'm just running a development. A container for development. I'm not running any service here, so the catalog service is not here. I'm not able to test properly my front-end application. What can we do? So now we need to update our dev workspace definition. So I need to switch back to the slides. And so I will, step 4, we will add specific containers for building and testing application. In particular, in this case, we'll add a couple of containers to test the application. So one is an API service. The first one is catalog. And the second one is a MySQL database that is the catalog DB. So I will use the command line. But this time I will do is and I'm in step 4. All right. So I've patched my dev workspace, so it's restarting. And what you can see is that now the number of containers, the final containers are 4. So because I've added 2 more containers. Before at the beginning, I only had 2. Now I have 4 containers that are running. And if I go back to my application, so okay, I need to do that again. Okay, so the application is starting, and it's listening on port 8079. So I can do, again, curl. And I will look for catalog. And this time is able to actually provide me some JSON output. So so that we made our development environment work. So now I'm able to do development on my front end application. But yeah, so I'm still the problem is I'm still on just a command line, and I like graphical IDEs more than command line ones. So what I will do is that I will add a graphical IDE to the dev workspace. So last thing, we add that final component that is called Visual C code, and it's another kind of component. It's not. We only saw containers before, so here we had added 2 more containers. The type is container, but now it's a particular one. It's the one that will run the IDE, so we call it plugin. Because it's a plugin that so it's a definition, it's the Visual C code is defined in another dev file that you can plug on any dev workspace that you have created. So let's do the final step. All right. So again, it's terminating. So the pod, you can see that it gets terminated, and it will be recreated. And this time, it will be Visual C code that will be running. So the number of containers is still 4, because we are actually injecting Visual C code inside the front-end container. We're not running it in a separate container, so that Visual C code has access to all the tooling that it was in our development container. Okay, it looks like it's running, and if I look at the dev workspace now, it has it has been updated, it's running, and that's the URL to access it. So if I go back to the here, and let's close one tab, and if I just do a refresh, instead of having my command line, there should be something else that should come out. So that makes it's too big. Okay. Okay, so this is just Visual C code, but running in the browser. So running as there is a Visual C code server that is running in the container, and from our browser, there is the Visual C code client that is connecting to the server that is running there. I still have my shell with my PS1 that I configured. I have also my Git configuration that has been automatically provisioned. I'm able to just start debugging from the UI now, so it's easier than what we had before. So it looks like, yeah, I think we need to yarn install. Yeah, it's possible to add some, I've already said that, but I haven't configured for that example, but it's possible to have an init container that run these pre-start commands like this one, but I haven't configured it here, apparently. So now the application is running. Visual C code figured that out, and I just can open it, and we can test it from here And also, if I put one breakpoint, I should be in the, yeah. So I just refresh and it gets stopped here. Okay. So that's it for the demo. So I think that I show everything. So this is the resulting customer source, the dev workspace. So we have been going through that. We have also added a few config maps and secrets for configuration that are specific for my environment that I don't want to version with the rest. So we have seen that it's fast, it's repeatable, and it's scalable. I hope that we make that point. And so to learn more, we are on the Devfile channel and on the Kubernetes Slack, or you can find us also on GitHub, the Devfile organization. There is the repository for the dev workspace operator source code. So yeah, that's it. So thanks a lot again. I don't know if we have any time for questions, but
we have 1 minute.
1 minute. Okay.
There is any quick question?
Thank you very much for the presentation. Is there some sort of image building process involved into the process? I mean, you put in a source code repository and a base container image, right? Is this a building process involved anywhere in this workflow?
No, I mean, so the image that is used is what we call a universal developer image. It's one image that we have built that fits 90% of the cases. If somebody wants to start, it can just use that image. Then there are two options if you want to customize it. You can either use so change the image, so use your image that you have pre-built before running the workspace, or you can actually specify, it's possible to specify, instead of the container, you can specify a Docker file, okay? But that's not, it's supported by the spec, the specification of the dev file as it. In terms of implementation on the dev workspace operator side, it hasn't been implemented yet. So that's something that is not available for that tool. But there are other tools based on the dev file that supports that.
So it basically copies the files and the source from the repository into this image and then runs it. Okay, thank you.
Yeah.
Okay. Thank you very much, Mario. We have now a 15 minutes break. Okay, welcome back. For our next talk, we have Nuno, who we will talk about docs inclusivity. So let's start.
Thank you. And thank you already. So yeah, my talk will be really light-hearted. So just relax, take your favorite beverage, and we'll try to do this together. So today, yeah, I will speak about docs inclusivity. That might sound weird, joining docs and inclusivity together, but it's from a Windows user perspective. So what we will see today, okay, I will quickly speak about me, why am I doing this talk, then we will go through, in my terms, let's say, on doc inclusivity, what are the challenges, but always keeping the positivity, so how we can help also. And if everything goes well, potentially, I will not sink with the boat, okay? So, first of all, who am I for the ones who don't know me yet? I'm Nuno do Carmo. I work as a tech writer for SUSE since 6 months. I'm a Portuguese living in Switzerland. I love a lot of things as hobbies, and I'm proud owner of 4 cats. Yay. During nighttime, however, okay. So during nighttime, however, I transform kind of, and I become what I like to call myself, the WSL Corsair, or the Corsair itself. I love Cloud Native, I love Docker, literally. I blog a lot about it. You can follow me on Twitter. And I'm proud owner of the hat you can see there, which is given to me by Brian Kettleson. The recognitions are just like, thank you, community. So, before we start our journey, I will do one promise, is that I will not speak about a certain subsystem, for the ones who know me again, of Windows. I know, that's shocking. So, when we write docs, the main challenge is that potentially we have assumptions. One of them, is that big enough? It seems small, sorry, okay. One of them is that Windows, currently, at least, is by far the most used OS in a desktop for any user, okay? However, when we come to developers, the trends, well, even though it's still the most used, it's way less now if we combine Linux, macOS, and others, okay? Not way less, but it's less, okay? So suddenly the developers seem to me not that much represented as a user compared. So the cloud native docs currently, when we go to any website, potentially that I went through, when I get to the examples, due to the developers being in other systems, right? The docs are more likely, or the examples are more likely written in Nix format, right? macOS or Linux. So curl this, pipe that, GQ, or whatever. So this brings some feelings that the users from Windows, right, well, feel a bit like Linux gamers. So who is a Linux gamer here? Well, one person, because he has a Steam Deck, but but okay, but you feel the pain over the years, right? You know what I'm talking about. So, well, Windows users now feel the pain of the Linux users, right? And in the cloud native perspective projects is like, okay, it seems that we have a disinterest from the Windows users, right? We are still the most common ones, but representatively in cloud native, it seems that we are nowhere somehow. So the problem is the same, but we are looking at it from different perspectives, okay? And again, the feelings are different. And of course, because of these feelings, then we have an impact. The impact, first one, is, again, like I said, that cloud-native projects somehow lack Windows examples or support, okay? Many friends call me from time to time and ask me like, okay, can you train this person, or can you explain how to do it maybe in PowerShell or the other thing that I should not speak about. And, well, from a Windows perspective then, a Windows user perspective, when I go to a website and I try something, then I find it hard to translate. So I found your projects hard to use. And might be not the case, but that's, again, that's the impact. So talking about the same thing, but again, not understanding each other. So here is like a personal view. So I call it from a Windows user because I'm one, but that's a personal view. So at the very, let's say, at the very beginning, I see a cool demo from you all, right? I see, wow, so cool. So then I discovered your project, and I'm like, okay, I should test it. Now, I go and read your blog posts, because I know you document your stuff, right? You document your projects in either a blog post, videos, it's out there. I know how to find them. Then comes the first question, does it run on Windows? Yes, no. Are the examples englobed with PowerShell examples? Because I'm from Windows, right? And finally, trick or treat. Well, too bad, no Windows example. Maybe the next project or maybe their next iteration will come with the Windows, let's say, examples. Or, hey, you did your work and actually I have a Windows examples, binaries, and I can use your project, so I can contribute also. Let's take a concrete example, shall I? With the, let's say, the first step, Kubernetes. So I went, you cannot see it, it's normal. It's a full page, but I went to Kubernetes and let's say that I want to install kubectl. The first doc here, you cannot see it, but it's using like PowerShell. So I have the example of PowerShell. Cool. Then I want to go a little bit deeper. kubectl as a shell autocompletion. Well, there's no PowerShell. That's, and by the way, I will rectify it after, but let me just go through the example. So there's no PowerShell autocompletion. That's bad. The good thing being in cloud native and open source projects is that we can then create an issue, right? And ask, well, can we get the PowerShell auto-completion, right? So rectification. Nowadays, it's done, and PowerShell has kubectl auto-completion, so that's good. When I did the slides, initially they didn't. It was like 6 months ago. So with all that in mind now, let's switch now for what I call the 3 layers of doc inclusivity. That will take what I saw so far and how we can maybe transform it. So the first step that I see, of course, in all projects is potentially if there's binaries and release notes. Okay, so we are all using some kind of GitHub or GitLab repos. So normally the binary should be there. Is there a Windows binary? Yes, no. Yes, that's on the good side. So I mean, I can use your project already. Potentially, there's no installation docs. So just question for you to answer yourselves. Tell me where I put Windows binaries to be executable like user bean in Linux, right? There's no answer. We don't have that. If there's no installer, it means that I have something on my pass. Pass on Windows is not as easy as pass in, on Linux, right? And suddenly, already, like just the installation can be complicated for some Windows basic user, let's say. So that's already a good room for improvement. If you have a Windows binary, try to think about the Windows installation, how you like it, okay? Then you have release notes, definitively. But then release notes, and I say like no examples for Windows, but potentially you don't have even examples on release notes. So we are missing something there. So what you think you built, this is where what we see from a Windows perspective. So we see the inverse of the scenery, right? So then, in terms of docs, so now we move away from the repository itself, we go to your docs website, and potentially it covers all the layer 1. So it means that he has the Windows binaries, he has the release notes, you have some installations, examples, but then your Windows, let's say, example or documentation sometimes comes as hidden. Okay, they're there, but they're kind of hidden. They're not like as present as the Linux counterpart, or even are just a note. So I'm talking about experience here. So suddenly it's like a small note, oh, for Windows, don't forget to run your PowerShell in administrator mode, right? But it's out of nowhere. It has no, let's say, real, I don't know how to say, but there's no real story here. It's just suddenly just a note dropped. So the thing is, like, if you write documentation for Windows, then assumption here, which is bad, but assumption is that you have some sort of Windows knowledge. And the problem is, like, you have Windows knowledge on potentially a certain version. Windows 10, Windows 11, pre-2000, 2021, H2, H1, we don't know. So suddenly Windows that was like, okay, we are unified, we are not like Linux where you have forks all over the place. Well, today you have a chaos from Windows XP that are still used somehow, to Windows 8, to Windows 10, and finally Windows 11. So this brings actually that your docs for Windows might just target your person that knows about Windows, and it will be one version. So in your docs, we built something really nice. Okay, so we have now a great doc site, we have documentation. The problem is, like, we don't know who will use it and might misuse it. Have you tried to go with a Bugatti in a... Anyway, so, oh, cool. So, sorry. I will talk about this one after. So, the last bit will be the command. So, command is like, you have your commands, right? So, let's say that you have, again, layer 1, layer 2 are covered. So now we have everything. We have the doc sites, we have the examples, we share about us. But then, what happens is, like, does your, it's in the good, but it's still a question, does your command output brings Windows example, right? When you do something like, I will take a concrete example here, which is K3D. K3D is Windows, or Windows compatible. We can run K3D on Windows, but then suddenly when you install a cluster with K3D, now I think they fixed it, but before it was like, okay, everything goes well, Windows, it says Windows everywhere, and then suddenly the last output is only Linux-based, because it has some command that you have to run on Linux. Okay, it's not. So think about also, after you build all that, go back to your actually binary and think about, like, what are the outputs? Do we have examples there to help, right? So it's not a place to be better, but okay, cool. So for example, when you think about Windows and Linux parity, there's, let's say, tips and tricks, right? One of them, if you look at especially Linux, we like to do, you don't see it, but I will share the slides, or the slides will be shared normally. So you have the kubectl, minus, minus, and EOF, right? And then you can put your YAML, and then you press enter, or EOF, enter, and done, right? We have actually a parity for PowerShell. It's written there. It's a bit different, but it still complies with it. So the PowerShell users can still just take your YAML and put it in a command line directly. A second example, our dear friend kubectl and JQ. So JQ, don't get me wrong, JQ is fully compatible with Windows. There are binaries there. But once again, where do you install JQ? Do you want to explain where to install JQ? during your own project, right? So here, what we can do is that instead of piping it through GQ, we actually have the JSON path directly built in from kubectl. So you can simply, or simply is not simple, but you can like change the approach. Okay, I talked about all that, but I mean, changing your docs and everything sometimes might be difficult. So you need help, right? So that's, nakama means friend in Japanese, by the way, so that's why. So first of all, the first help that you can get is to choose actually a doc environment. We have many of them, Hugo, to mainly name maybe the most known one, and then we have something called Dockers. I will speak about it later on, or after just that, and MDBook, MKBook, or MKDoc, sorry. All these layers here, all these frameworks use Markdown. So there's a kind of standard already to, in terms of language, okay? And then if you want to migrate from one framework to another, Markdown is your friend. Just be careful, just mind. Sometimes you have like what we call admonitions that can be different between the frameworks. Then, when you are asking to people to help you on your project, maybe they don't want to install Hugo. Maybe they just go to your GitHub or GitLab and they try to edit directly the file. But it will be nice to have a rendering, right? What I call the preview. So here is not a shameless plug because I don't work for them at all, but Netlify has a really neat preview, and I guess others have to, right? So it previews your PR, and so you can see if nothing is broken and anything. And the persons writing the docs or contributing to your docs don't need to suddenly install the whole framework, right? So here, it was for one of our projects. You will see here in the deploy preview that it creates a link. You just have to click. It's inline in your issue, so it's really easy also to use. Then, in terms of content, your docs are great, but sometimes I have the same questions. Where do I start, and where does it end? Okay? To help you order that, we have something that I discovered while working at SUSE. I didn't know about it, but it's called the DView paradigm. It's a way of ordering, actually, documentation between tutorials, how-to-guide, explanations, and references. I will provide, like it's docs.devio.com, but in between, you see like these lines. It tells you like, is it more technical? Is it more professional? What should go where? And the docs suddenly get an order that are also easy for you to maintain. Finally, not finally, sorry, the storytelling. That is a bit personal now. People like to have technical documentation. Others like to know how to use it right away, so your quick start, let's say, and others want to even understand what for. The storytelling here, for me, was the best one. Like, I will start here, and where does this project leads me to do, okay? So there's a story. Here is Nuno that wants to deploy a Kubernetes cluster and deploys an application on it. With our tool, how do you deploy the application? How it goes, and step by step, okay, you have a trail. And your users, at least the first time, they don't get too much lost. Then, of course, you have to have your technical docs, right? So these are more developer-oriented. If you have CLIs, if you have like APIs, then it's up to them to go there. But the user might not be a dev, okay? Finally, try, and it's the hardest one, try to not have assumptions. Your knowledge is not universal. For what you think it's simple, easy, just have to, these words, right? are already an assumption that you think that the person that will be reading your documentation knows as much as you. So try, again, maybe with storytelling or not, but try to bring the persons with something like a background. First, here is the prerequisites. You have to do that before you start, okay? Even just links, look at this one. But don't assume that the person already knows where a binary is installed, how to use it, and so on. The second friend, of course, is the community. So I put here Windows OS users to feel welcome, because my talk was more about Windows users, but it can be like any user. Make your users feel welcome into your communities. I know you are doing already a great job, right? But sometimes there's not judgment, but it's more like, okay, do you have an example for that? Oh, no, we don't. And stop there, instead of trying to bring them. Oh, but what do you need for it, right? I don't say it's the case. I just, let's say, just to mention it. And Cloud Native, at least how they presented me, is OS agnostic. Well, that's pretty much Linux agnostic for me, but okay, we'll get in there. Then, Windows knowledge sometimes is not shared. Like many times I go to communities, Slacks, or something like that, and everyone knows how to do something in PowerShell, like the two examples that I provided, right? But they keep it kind of for themselves. It's not documented anywhere. And now the next community member comes and maybe he or she, them, don't know it. So try to encourage also that Windows is not that bad. If you know something about Windows, we can document it. Especially the command line. Yes, Windows users use command lines, by the way. Finally, market your docs. Okay? Think about docs first, if you can, but market your docs. It's good first issues. For people who know me from back in the day, I didn't know how to help as non-developer in Cloud Native. And everyone that helped me told me, start with our docs. Look for typos. Look for ways that you can improve potentially. And I start using their projects and I start contributing. And that's how I get started. But there's like a building, right? If I don't know that you have good first issues, then for me it will be difficult to know how to help. And so that will be the sound potentially, like a certain GM told last year. You have it? No? No luck? Okay. She was just saying, like, we welcome everyone, even Windows community. So that was the video. I will give the link. So, to complete the last part, let's say that how you can help, again, my slides are all messed up, so let me just do this like that. Okay. So, content. Check your own docs. Look if there's some assumptions in some parts, especially the quick starts sometimes. Okay, the quick starts, we think, let's say, inverse. Quick start is like explain less and you can get your project running in 5 minutes. Cool, but if you don't have prerequisites, then it can be either 5 minutes, it will be half hour or 1 hour. Review your examples. Can they be more generic, like the GQ? Okay, can I use more like the, even though it's maybe not the best way as you do it on your daily job, maybe it's the best way to share. Promote your docs and tag issues, okay? And one last thing. I lied. So, if your project by any means cannot run on Windows, it's still okay. We are out there. We can help you with, okay, WSL2. So, starting Windows 10 or Windows 11, there's the subsystem for Linux. I won't speak too much about it, but there's the subsystem for Linux, and your projects can run there. And if you don't think they can run there, challenge me on Twitter. I'll find a way. That's what I've been doing for the past years. So I'll bring your project to live on WSL2 on Windows, potentially. Okay? And I'm not alone. That was it. Yep, thank you. So I finished earlier.
Thank you, Nuno. There are questions?
Yeah, thanks for the talk. So what happened is, like, I was doing a lot of trainings, and most of the time, just to avoid because as you mentioned, yeah, there are a lot of people using Windows. So to avoid kind of writing documentation for people using Windows, we're just spinning up VMs in the cloud, and they will be like everything running Linux, and putting them basically outside of the comfort zone, because they're assuming they can open VI and they can write whatever is reported for. So what would be the approach of actually kind of like making it easy for myself as well, if I'm running a training, for example, and I don't have knowledge enough, to be sure, sincere, I don't have knowledge to actually test stuff in PowerShell and make it work for them. So what would be kind of like a middle ground of actually make it happen for everybody to who's on Windows too?
No, that's a very good question, and that's something that, if you know Brett Fisher, for example, he's doing also a lot of trainings, and he's using some technology to spin up the VMs. But your point was really right. He's like, okay, but now there's an assumption that potentially you know Linux, right? The middle ground, seriously, I don't know, because there's no real technology today that can, let's say, abstract the Linux of the VM and just run, let's say, your example. Can it run on a container? I would say it's the middle ground, okay, because now your commands will be the same at the starting point. And if not, then if you need a VM, then it will be always tough. That's why I say, like, what I say about WSL2, because it's mine, but it's at the end of the day, it's also a small VM, right? So your VM, unfortunately, is like, if they need to go through Linux, try to use maybe advanced or UIs, right, of CLIs, like Code, like Eclipse, that we saw before, like the dev environment they were explaining just before. I think it's great, even for teaching, because now you abstract nanos, VIs, Emacs, whatever, right? So if you can use like UIs-based applications, or even on Linux, but that could be generic, like code, for example, then try to do it, okay? Instead of VI this file, code these files. I know it's might be different, but it's at least the Windows user, let's say, it will not get too much lost. Also, with code itself, and sorry, I'm talking about VS Code, but maybe others have it, like IntelliJ or something like that, but try to use the remote also. Like, if you build your image on the VM, code can connect, right? He has like the remote containers, remote SSH or something like that. Try potentially just to explain that part. But again, like I said, now it becomes your prerequisite, right? Because you should not assume that people know how to connect to a VM, even with SSH today, because maybe Windows, they don't know how to do it. So that's that's the tricky question, right? Where is the middle ground? I would say always containers, or can your application have like a Windows binary, but then try to write generic, right? Generic commands line. Pipe is great. PowerShell users, they use pipes, no problem. Command users, because they're there, they use pipes, but it's less common. So if your line can be a one-liner, cool. And for you, you don't have to understand PowerShell, because your command is your command, right? So if you can connect, then it's good. If not, there's no middle ground. There's just more explanation on your docs and your training especially. But yeah, thank you.
Any other question?
Okay.
Thank you, Nuno.
Thank you.
this talk, we have Victor. We will talk about enforcing a secure supply chain on Kubernetes. So enjoy. Victor.
Hello, everyone. I'm Victor Cuadrado, and I'm here today to talk about how to enforce a supply chain on Kubernetes. This talk was an original submission by a colleague and I, by Raúl Cabello and I, for Victor, for the, sorry. Okay, let's snap out of it. For KubeCon. Who am I? Yeah, I was thinking about the next slide. Who am I? I'm Victor Cuadrado. I work right now in SUSE as an open source software developer. I'm going to keep it short. If you want to contact me, I don't have Twitter, but you can contact me in the Matrix network. So you have there my handle, and you have my personal page. Okay, so what's a supply chain? I suppose everybody knows about that. Everybody has maybe seen this slide already today and the previous day and so on, which is super nice, and it's what should happen. This is a supply chain. For us, the package in the cluster is going to be a container or a Helm chart. So for obtaining the container, we need to build it. And for building it, we need the source code. So here we have the chain. Also, the container is going to have dependencies. It's going to have container layers. It's going to have libraries and so on. So for those dependencies, we need also a place to build it, and we need the source code. And why do we want to secure the supply chain? Maybe yeah. Maybe you guys have heard, you folks have heard of this week attack on Rust, on the Rust supply chain. There was an attack with a type squatter attack with a package. They just pushed a package that had a similar name of another crate, and they tried to get into people's chain that way. Or maybe you have heard about the PHP upstream problem that happened a bit ago, where they just compromised their forge, their source forge, and injected two malicious commits in their source. Or maybe you have heard about the SolarWinds IT management software, which they compromised their build service and injected a malicious binary there that was injecting malicious things on every and each build. Or maybe you have heard about the CodeCup product, where they just got a hold of some credentials for their bucket and substituted the end package right before the consumer. So yeah, you get the point, no? So how do you secure that? Okay, you need provenance. You need signatures, you need software bill of materials. You need to know from where things are coming, and you need to trust where are they coming from. You need transparency logs, just to be able to check publicly that that's veritable and trustworthy. You need also to scan continuously for vulnerabilities. And you need to save the metadata somewhere in a database, maybe it's going to be in Toto and so on, and then you need to check regularly for those results. And you need to do all of that following best practices. You cannot just maybe do it alone. It's going to be difficult, and maybe you're going to miss things. So talking about best practices, you can implement this in several ways. One way of implementing it is with Sigstore. What is Sigstore? Well, Sigstore provides some specification and some workflow. This is a vendor-neutral effort from the Linux Foundation. And it's really nice because it provides an automatable workflow. It can be just put on CI, which is what we want. No? I mean, for sure, all of you have, or a majority of you have dabbled with GPG and needed to create the public keys and the replication certificates. Maybe you have, I don't know, UB keys with sub keys and so on. Yeah, I've been there. It's super nice. What happens about the Web of Trust? Yeah, the Web of Trust, it's kind of broken since 5-7 years because it's been attacked fully. You just do it on your own. You just go around looking at people's keys and IDs, and let's be honest, no. I love GPG, but no. So instead of that, we can do it in a different way. We can shift a bit of the trust, and we can use an automatic key management workflow. Sigstore calls it keyless. We will see how it works. It uses basically some PKI infra to set everything out, and then a transparency log. And for us, this is great, Sigstore, because it supports container images, supports binaries, and also supports OCI artifacts. Wasn't modules, wasn't binaries, which you will understand why is important later, and Helm charts. And yeah, I mean, it's really difficult to convince you in one talk that this is trustworthy. I don't intend to do that, but you don't need to trust me alone. You can see, for example, Kubernetes since version 124 it's signing everything with Sigstore, all the images and so on, and it will keep signing them onwards, which is super great. Let's see. Let's start with signing, and then we go to verifying, and you get an idea of the keyless mode, which is the nice mode of Sigstore. How do you sign in keyless mode? Here is one command. You can see cosign, sign, and then the image. That's it. What happens here? First, you need identity information of the developer. I'm the developer, and I want to sign this. You need the identity information, and you need the context of the signing. On which build platform was it built? How, and so on. For the identity, we just delegate that to an OIDC service, or an OpenID Connect service provider. And that's what's happening here. You get a URL, you go to the URL. This is predefined by the tool, and it shows you 3 providers of OIDC. You, of course, can just pass whatever URL and use your own Okta, for example, or Epsilon, your own organization OIDC provider. You don't need to use any of these. Once you authenticate, then you are authenticated, Sigstore knows about it, and what happens here? Well, Sigstore creates a short-lived cert that you would use just for signing, and then you'd get discarded. You would normally use it only once. This certificate comes from the Sigstore PKI as a certificate authority. So it comes signed with the Sigstore's root cert. And Sigstore also publishes the public key of that certificate into the transparency log. So then everybody could just check that that has happened in that specific moment, and the signature has happened in the specific window where it could be used, because it's a short-lived cert. And then you just sign with it and dispose of it. I understand that this is a bit convoluted, but it's quite nice. If you want to learn more about this, I have more slides, and maybe we can just stop after the talk, and then we can go through it. So you sign. What happens when you sign? We're talking about container images. An image tag it's just created and pushed to whatever registry. In this case, I'm using GitHub, maybe because everybody knows about GitHub. And what is a signature? Well, it's just a new image tag. You can see it there, the first one. And the tag is the image digest, the checksum of what you are signing. That's it, nothing more. Maybe one can understand that already. And how do we verify? Well, instead of doing cosign sign, we do cosign verify. In this process, we have an artifact. From the artifact, we get the checksum. From the checksum, we find the signature on our registry. Once we get that, then we can go through what happens here, which is basically we check the signature cryptographically, just to see that it has been signed by the public key that matches and so on. We check the chain of certificates from the root CA of Sigstore. Then we can go to the transparency log and check that the public key was issued in that specific time frame where you could use it. And then after that, of course, we would need to check ourselves the ID and the context. I mean, we have checked that there was a signature, but then it needs to be signed by the specific person that we trust. No, I mean, that makes sense. So yeah, it's a bit convoluted, but let's see, how do we shift the trust? How do we trust keyless? Well, we need to trust the developer's identity. Normally, that's a list of emails or something like that, a list of handles in their source fork. Normally, it's embedded in the source code, or it's embedded in a file in the source code, and so on. And we need to trust the infra, their code forge, and their builders, and so on, which we always need to trust. Now we have the OIDC provider that we are delegating a bit of information normally, but that could come also from the organization of the developers, so you keep trusting the same group of people. And then you trust the PKI infra and the transparency log, which you can also roll your own, and you expect big organizations to also roll their own. Why not? And in contrast with GPG, for example, where we would just check the public keys in the Web of Trust, check that the things were signed with the correct private key, then check that there was no revocation certificates somehow at some point. Now we just have the signature and then the public key and the chain of certs and so on, and the timestamp on the transparency log. Okay, this is perfect. Now we know how to sign and verify. But we need to do this automated because we want to do it. How do we do it in CI? If you remember, it was all automated. The only thing was
the OIDC token? Well, it's a CI. We just use an OIDC token inside of CI. What's the state of the art right now? CIs that support OIDC tokens are GitHub, as I know so far, GitHub, CircleCI, and Google Cloud Products. With GitLab, we would need to, it's still missing the generic OIDC tokens because a token, it's a JWT token, needs to have the audience set to Sigstr, so it can only be used with this. And it's also missing some tooling on the Sigstr side, on all the utilities, but it will come. Also, you can use a service account token volume projection, which is new since Kubernetes 120, which is quite old, actually. What that means is that you just put the token on the node, and with this, Kubernetes would expose it on the pods. And inside of the pods, you can reuse it in I don't know, Tecton, for example. Okay, a specific example. This is a GitHub CI workflow. It would be, as usual, you just build and push your image. The last 4 lines are the new thing. Basically, getting the cosine CLI and doing a cosine sign. Done. You're done. That was easy. How do you verify that? You do the same as you would do before, cosine verify. The only thing that has changed is the things that are set on the signature and come from the CERN, which is the issuer, in this case, token actions GitHub user content, which tells you that it was signed inside of the CI, and the subject, which is the context. If you look at the subject, you see it's github.com, bitquad, app example, and then the file name and the path. You can match for that subject. If you match for the whole thing, you would only accept that specific signature. If you match, but you stop in bitquad app example, then you would trust everything that comes from that specific repo, even if it's another workflow. And if you stop in bitquad, for example, then you would trust everything that comes from me. That's the gist of it. Of course, you need to follow best practices. If you were to just match on your own, and somebody creates another user that is called bitquad2, if your regex or your matching is not good, then you could match it also. So, you know, these things, there's little gotchas everywhere, and that you need to follow best practices, and you need to delegate at some point, because it's a lot of things to think about. Okay. We know how to sign and verify. We know how to sign and verify in CI. We need to enforce it in the cluster. For doing that, we can use a thing in Kubernetes, which is a dynamic admission control. Maybe you all already know about it. A gist of it basically is you have a pod. You can see here on the left, we have our happy user, and then a bit of automation hitting the API server, which is the blue box in the middle, and then the ADCD on the other side, which where things would end up, no? Let's say that the user wants to instantiate a pod, and we want to modify that pod and add an annotation to that pod. Well, the user sends a JSON request, it gets authenticated and authorized, then it goes to the multi-tenant admission, and we have some webhooks that we can plug. By plugging those webhooks, we change the JSON request. In the JSON, we just add annotation, prod, that's it. Then goes to schema validation, where it gets checked. So the JSON keeps being conformant and it's a Kubernetes object, and then it gets validated. Maybe we only want to validate if the annotation equals to prod and not test. We can do that also there. And then it goes to a DCD and the pod goes live. We need a specific example. In this specific example, I'm going to use KubeOrden because, to be honest, it's the project that I'm working on with my colleagues, so I know it by heart, and it also has some niceties. KubeOrden, of course, is open source from SUSE, but we welcome it's completely open and not under any organization in GitHub related to SUSE, so we intend to give it back to the community. What is KubeOrden? Well, it's a policy engine. Of course, it monitors and enforces policies, depending on how you specify them. And it comes with Helm charts. You know, you install it with Helm charts. It defines 3 CRDs. You just define the policies on the CRDs, and so on. In this case, it's written, the server and the libraries are written in Rust. So for Sigstr, we will need to use the Sigstr crate. Sigstr didn't have any Rust crate. We needed to implement it from the ground up, and it's there in Sigstr upstream. if you are a Rust developer and would like to contribute, please feel free to use the crate. We have several companies and people contributing to it, so it's great to see that support on Sigstore and Rust. And KubeWarden has a nicety, which is that all policies are WASM modules. So you can, a WASM module is a WASM binary. You can run them compiled from Rust, Go, Swift, TypeScript, Rigo. You have your policies on Rigo, on OPA, or Kyverno, and so on. You just compile them to WASM, and you run them. Why WebAssembly is so nice? Well, it's small, it's polyglot, it's secure, it's portable. WebAssembly, it's just a binary instruction format. It's a common architecture that you can just compile your programs to. And it's a sandbox runtime VM, and it's completely secure in that sense. It's way more secure than other things. I'm not going to get much into that, but it's nice. For us, it means that we can just keep using your preferred language. You don't need to learn a common, like a domain-specific language. You just use whatever language you want to create your policy that it's supported by WASM. And then you just use Git, and you use your libraries of the language, and you get done with it. And then it's distributed by OCR registries, because WASM modules, WASM binaries, have first-class support on OCR registries, so you don't need to do anything. And the policies can be executed outside of Kubernetes. You can just run your binary outside and check that it's doing what it's supposed to do. OK, with a specific example, how do you sign and verify a policy in CI? With our case, we would just do the same and check the subject. And in the case of KubeWarden, you can ensure it also locally with a little tool that we call KWCTL, which can do it outside of the cluster, or you can just run the policy outside of the cluster. For all the policies of KubeWarden, we have a hub where you can just submit your personal ones. Signed policies are marked as such in the hub, so that's nice. And now we have our policy. It has been signed. It was signed as a container image. You didn't need to do anything special nor learn about it. Now you want to ensure that all your policies in the cluster are trusted. You just configure KubeWarden to check those. To get a default config, you can just do a KWCTL and get your default config. For example, this one that would validate and trust all the KubeWarden policies. And maybe the next step now, you have the policies trusted. You want to trust everything inside of your cluster, all the container images. How do you do that? Well, we have a policy written in Rust. You could just write your own if you wanted. This policy checks all the containers in a pod, all the container images, all the init containers, all the ephemeral containers. So you are sure that all the containers are checked. How does it do? It's just a policy. Gets a JSON request for the pod, and then goes to all the container images. Are the container images signed? Yes. Are they signed by the person that you want it to be signed? Yes or no. If no, it rejects them. If yes, you can approve them. But yeah, you have container images, the tags are mutable. You can push a container image 1.0, and next week you push again 1.0. That could be an attack vector. So the best practice is to mutate the definition of the pod. And you mutate it by adding, we will see it later, how we mutate it. How do we instantiate that policy? In KubeWarden, you just create a cluster admission policy. You can see it there, nothing special. Spec.module, for those in the back, it's just the policy. The rules, it's just for pods, create and update. And then mutate in true. And then some settings for the policy. In this case, I'm putting image, all. I want to check all the images. All the images need to be signed by this specific workflow. You could just, the subject, you could just put an asterisk and only check until you want, and we will make sure that it is sanitized and so on, and it will get checked. Then we just wait for the cluster admission policy to be active, and it's enforcing. And now if we try to instantiate a pod with untrusted images, let's say Nginx, which we know that it's not trusted by us, not signed by us, we try, and what happens? Verification of image failed, no signature found in this case. If we try to instantiate something that is trusted, we just launch the pod, and it mutates. There, in the end, we get kubecontrol get pods of the image, and the image has the tag and the digest at the end. So we mutated, so nobody can substitute that tag in the future. So what's next? There's a lot of things to secure a cluster. One part is the software bill of materials. We have talked about our container images, our policies, and so on, but we need to do it recursively now for all the dependencies that we have. Talking about software bill of materials, it's a complex topic and it's a big one. I think it deserves its own talk, to be honest. The way to do it would be, for example, using in-toto for the specification of the metadata, and then you would use cosine and the Sigstore utilities and Sigstore libraries because they have support for that. And then this is a community effort. We all depend on something, no? So please sign and verify anything and everything. Maybe you don't use Sigstore, maybe you want to use something else, but please sign and verify. And at some point, we're going to have the whole stack signed and verified, and it's going to be great. And I would be happy if that happens. And I would be happy if that's what you get out of the talk with. And then about other KubeCon talks, I have some colleagues going to KubeCon. One that I really like about WASM and so on is what if the Kube API server could be extended with WebAssembly? You have seen KubeOrder, you have seen the policies written in WASM. Now imagine that it's all inside of the API server. I don't want to spoil it, but it would simplify a lot of things. And then also from my colleague Rafa, we have also Kubernetes is your platform design patterns for extensible controllers, which has a lot of learns and know-how on how to design a nice controller from Rafa and Fabrizio, also from SUSE and VMware, and that's it. How to get involved? Please come to us. If you want to talk about KubeOrder, here's the website, here's the policy hub, here's our GitHub, and so on. If you want to talk with me, then you have there my matrix handle, and that's it. Many thanks.
Thank you, Victor. Do we have questions? Thank you very much again.
Many thanks.
All right. Thank you very much for coming. My name is Jan. I'm a software engineer at KubeCon. And today I would like to share with you my journey writing a little geeky esoteric tool called Reverse Kube Resource. And what this thing does, it takes YAMLs and generates Go files. I would imagine right now you might be a little confused, and don't worry, I will try to elaborate and make this a little bit clearer. So on the left, you have a perfectly fine Kubernetes YAML manifest for a service account. And for whatever reason, you decided that you would like to have the same thing, but written in Go, matching one-to-one. Thank you very much for asking. That is a great question. I made an observation, and I think you potentially may have made a similar observation. Large amount of applications in Kubernetes are distributed using YAMLs, whether it's in a form of Helm chart or customized templates. With the rise and increased popularity of operators, you will frequently find that your resources that were initially written in YAML are now also written in Go. And then you have to maintain multiple places. Also, sometimes you can write an operator in Go that is encapsulating and enhancing some third-party application that is distributed with YAML. So you end up doing one thing over and over again, and that is keeping yourself up to date with both YAMLs and Go files. Reverse Kube Resource is a little tool that can hopefully help. And now is the geeky part. I will try to describe the algorithm. It starts with a YAML parser. And this is a huge YAML file. The content is not actually all that interesting. But the first thing that happens, it splits on a document separators. Then it picks the first YAML document, and it actually goes in iteration over all of them. Let's blow this up a little bit. And luckily, there are packages in API machinery and client Go that are ready to be used. With these, you can get runtime objects of a proper type and with all the proper information that you need, which kind of already gets you 90% there. but as you see, there is a lot of extra information, a lot of craft that you wouldn't want necessarily in your Go file. Luckily, API machinery is really great, and there are other packages that you can use to get unstructured. Unstructured is another runtime object, which is essentially just a map of maps, kind of recursively defined. And with these two runtime objects, you have essentially all the information you need to write down the Go file. The second part is a runtime object processor. So these two, they're the same that were on the previous slide on the right side. They just moved to the left. And you have those two runtime objects. The first thing every Go file needs is a package. And then we abuse reflections. With reflections, we can figure out that from the first runtime object, we get an import with a proper path. We have a variable and its type. And then using API machinery, by the way, API machinery is great, if I haven't said that already, you can use the object meta interface to get the name and all the ceremonies around the variable. Then we abuse Go reflections again. We recursively go into object meta. We can skip type meta because all the information present in type meta is already present by the runtime object. And we know that there is a new import path. We know that there's a new field called object meta. And then we recurse again. Let's abuse reflections a little bit more. Get a name and a namespace. And that is where we can actually safely terminate. Despite the fact the first runtime object has a lot of extra information, the unstructured object helped us to figure out what is necessary. There is a little bit of post-processing involved. The AST utils, they have very convenient way to organize your imports. And voila, you have just translated your YAML into a Go file. Thank you very much.
Okay, thank you. Up next. Okay, Corey. Hi, everybody. Just to let you know, we have added some folks who are not actually on the schedule out here. We had a board for signing up. We had a few extra sign-ups at the end, and then I'll be doing a closing to thank the volunteers and the sponsors and everyone.
Yeah. All right. Hello. Welcome. So I will quickly try to describe you what you need to use in addition to default value, in addition to the some skeleton values on the deployment files. My name is Koray. I work for KubeCon remotely from Istanbul, and well, interested in all cloud technologies and stuff. So when you want to make a deployment, so this could be, I mean, you could be someone new to the Kubernetes world, or maybe a company working with Kubernetes for quite some years. If you go to the Kubernetes documentation, or if you use a VS Code plugin, you will get this YAML file, which is the bare minimum to have a deployment. But the question is, okay, your application will work with this YAML file, but the question is it secure and reliable? First thing I will talk about is the quality of service. So you probably know there are three quality of services in Kubernetes. It's guaranteed, or burstable, or best effort. And the YAML file that we just saw is on the best effort because we didn't define any resources. So it has the lowest priority and will be, your pods will be killed in case of out of resources of the system. So what you need to do to have other quality of services, you need to add some resource definitions, requests, and limits to your YAML file. If you define them differently, then you will have at least guaranteed this request value. So this is burstable. class, or if you define them with the same values, then you will have the guaranteed value. You will always have these resources for this container all the time. And then you need to define the probes, especially readiness and liveness probe, because you don't want your container to get traffic before it gets ready. Maybe your container will need to do some stuff before that. So you need to define a readiness probe that you make sure that you are ready to get some traffic, and also liveness probe to check if your application does not have any deadlock issue or any other problem. So that if there's an issue, Kubernetes will be able to restart your pod and then continue working. For security part, you need to add the security context, especially you need to run as a non-root user. Your container, if you are interested or if you are asking why, then I would suggest to search the internet for container escape vulnerabilities or issues. Also, you should define a read-only root file system. By default, these have the, so for example, read-only file system is false, but you should define it as true. And you definitely want to terminate your pods gracefully. What happens is that basically when you want to terminate a pod, Kubernetes send a seek term to PID1 of your container. And that part might be tricky, I'll come to that. And the default value is, for timeout, is 30 seconds. And if you see that your application always waits for this 30 seconds, then you should check your Docker file. Because if you, in your Docker file, if you define your CMD instruction as the shell style, then the shell will take the PID1, and that one will be killed, and your application will continue to run. And if that process needs to do some cleanup, it will never do it, and you might lose data or other stuff. So for reliability, you need that. And also, if 30 seconds is not enough, then you also increase it. And I would definitely suggest to distribute your pods. Of course, you will have more than one replicas, but running those 2 or 3 replicas on the same node is also not a good idea for reliability. So defining an anti-affinity rule to ask the scheduler to schedule your pods on different nodes of the system is a nice idea. So all combined, your spec section for the deployment will be like this. And maybe it would be a better idea to check for those things with some OPA rule or something else to make sure that all your deployments have at least those values defined. Thank you very much. And,
My name is Babur. I am a developer advocate for Apache API 6. It is nowadays one of the fastest growing top project of Apache Software Foundation. And today I am going to briefly present to you low-code plugin orchestration with Apache API 6 API Gateway. APIs, by now, we are all familiar with the term. Every service we use today either uses an API or is an API itself. And the APIs are central in building and delivering your services. And we know that our success of the services depends on the integrity, availability, and performance of our APIs. And the role of Apache API 6 in building and delivering cloud native and large-scale microservice APIs is very considerable. It provides rich traffic management features. It's fully dynamic. It is fast, straightforward. And then it's open source API gateways most importantly. And also, besides that, it provides ingress controller for Kubernetes. My colleagues soon in KubeCon are talking about ingress controller more. And next, plugins are additional components in API 6 that can be plugged into the API gateway. When using API 6, you must be faced with multiple types of plugins, including it covers authentication, security, traffic control, serverless, and many more. It has currently more than 50 built-in plugins, let's say. And during the technological selection, of course, the most important consideration for the development team, you need to the chosen product to match the technological stack or not. With a specific programming language or not. For example, API 6, you can write any plugins in the favorite programming language you are familiar with, including Java, JavaScript, Go, Python, and so on. And Apache API 6 is a first open source API gateway with a built-in dashboard. It offers flexible and powerful interface for developers to use, where you can also find plugin orchestration, and also under the hood, it uses admin API to talk to the, let's say, API 6, how to administrate, etc. But however, there are some challenges, right? Plugins I covered above are not unable to, let's say, meet all the needs of enterprise. Sometimes we need to do some custom plugins of existing plugins, and or the plugins actually written in programming language specific. We need to do some customization again. And the second problem again, like we need to use many plugins together. And there's a other actual problem in many open source API providers that has been open source so far. And however, with the low-code plugin orchestration capability of API 6, you can easily solve above-mentioned problems. Also, you can orchestrate existing plugins in a drag-and-drop way from the existing plugins to the dashboard. And you can also combine different types of plugins to create new plugins together. And as you can see, API 6 dashboard lists currently available plugins on the left side, on the right side, the dashboard. We are easily drag and drop all the existing plugins to arrange them. And we can define some conditions, and as a result, it's a simple process. We have ready custom plugins. We can also download the JSON structure of it. And here, the simple scenario, as you can see, like how we are restricting the API calls to our APIs from the external IP address by using IP restriction plugins. And together with, for the internal calls, we need to kind of restrict the number of calls or requests to the API. So here, and you can also, of course, create a very comprehensive plugins orchestration with the help of dashboard. So I'm leaving out all necessary references here out there, and please feel free to reach out to me if you have any additional questions. We have very good documentation. Of course, we are translating nowadays from Chinese to English. So thank you.
All right, thank you very much. Up next, Francis. For those watching on the stream, the video is going to be turned off for this one.
Okay, so hi everyone, my name is Francis Laniel, and I will present you my work about adding an eBPF-ready kernel 5.10 for Minikube. So, first of all, what is Minikube? According to their README, Minikube implements a local Kubernetes cluster, and Minikube primary goals are to be the best tools for local Kubernetes application development and to support all Kubernetes features that fit. So, basically, to deploy a local Kubernetes, Minikube offers you 3 drivers. You have the known one, you have the Docker one, which uses Docker container to deploy Kubernetes, and you have the KVM one, which will use a virtual machine to deploy Kubernetes locally. In the remaining of this presentation, we will focus on this one. So, I wanted to test the capability CatBPF, which was added in kernel 5.7. Sadly, the kernel provided by Minikube is version 4.19. So I would like to bump the version of the kernel provided by the Minikube VM. To build the Minikube image, Minikube uses buildroot. Buildroot is, according to the website, a simple, efficient, and easy-to-use tool to generate embedded Linux system through cross-compilation. Okay, even though buildroot is targeted to generating embedded system, it can also be used to generate virtualization-ready image, for example, with the make QEMU x86 64 devconfig. So basically, what I did is that I run make menu config, which enables you to configure buildroot to generate an image. And I bumped the BR2 Linux kernel version for 4.19 to 5.10.67. Sadly, I had a problem during the build. Indeed, this problem was generated by sysdig. It was a problem due to this version of sysdig, which was 0.23.1. So I bumped it to 0.27.1. I was able to get an image. Sadly, it doesn't boot. So I run make Linux menu config to add config to the kernel running inside the image. The first option I need to use was config tmpfs because the init inside the image just tries to mount a directory as tmpfs. The second one was config PCI to be able to use the Ethernet network inside the image. And the last one was config bridge net filter because kubeadmin actually needs a file under proc/proc, which is added by this configuration. And at this point, I was able to get an image with kernel 5.10. Sadly, I also want to use eBPF option, so I added the following option, and this time I also had a problem with building the image. Indeed, when you try to build a kernel with config debug info BTF, the kernel will rely on the tool called PAL, which wasn't inside buildroot. So what I did is that I added a recipe to build PAL before building the kernel, and at this time I was able to get an eBPF-ready image with the kernel 5.10. So, to conclude, now an eBPF-ready kernel 5.10 for Minikube is available. Sysdig bug was fixed in upstream buildroot, and also a PL package was added to upstream buildroot. So if you have an SBC somewhere and that you want to do eBPF on your SBC, you can now do it with upstream buildroot. As future work, I would like this work to be merged in upstream buildroot. Sadly, for the moment, it is still a pull request. And I would like to keep up to date the upstream buildroot package that I added with this contribution. Thank you a lot for your attention.
Thank you, Francis. Okay, we're turning video back on.
All right, welcome to my small talk. Let me talk about KCP. KCP is a kind of research project, a prototype, which we are building to reach 1 million clusters, to provide 1 million clusters. At the same time, we solve the problem of namespaced, or rather workspace CRDs. You will see in a second how this works. 7 years ago, Cube got namespaces. And at the time, you see the difference between proposal and implementation. 5 days, different times than today with caps. Goal was to have something simple. And I'm not sure it was the right decision, and we are trying to think about, to prototype, what if namespaces are more than just namespaces? They should separate much more than just a name. Like discovery, CRDs, like everybody wants. A different URL you can use in kubectl to talk to the cluster. Permission models, and so on and so on. So KCP is about, among other things, about scratching namespaces, use workspaces, parentheses, there are still namespaces, but you will not want them. They are useless, basically. So workspaces are the new namespaces in KCP. That's easy. We want 1 million of them, like 1 million users in the workspace. Every workspace is like a cluster. And people should think about workspaces like about namespaces today, but not about clusters in the today sense. Like a cluster is not this API server, scheduler, controller manager, and 7 other things, and nodes. No, forget about that. Just logically workspaces. That should be the concept in the mind of people. If you want to do that, it's not enough to just have many, many cubes, right? Running 1 million, it's not feasible. Nobody can pay for that. So we need something else. What the user sees on the right side, they see cube, and they operate against cube. They think they have the complete cube in front of them. But behind the scenes, on the left side, everything is radically rethought. Sharding plays a big role. One of those shards hosts many workspaces. Like today, one shard, one API server today has many namespaces. Same thought here, but again, about real clusters. Clusters in a sense that users inside of their workspace, they are administrators. It's a full cluster. They can do everything they want. They can install software, operators, CRDs, everything. But 1 million of them. There's a data model. Workspaces are nested, so there's something like, at least in our prototype implementation, there's an organization, which is a tenant basically inside their workspaces, and every workspace has open API, discovery, namespaces as well, permission control, airbag, quota, config maps, secrets, everything you know from Kubernetes minus compute, minus pods and deployments. But there will be a way, or there is a way today we are implementing to re-add compute to this model. But when you start, they are basically just the core. All right, so quick demo, how this will look like. There's a kubectl plugin, WSS, which is a shortcut for workspace, of course. We are in root demo. It's an organization called demo. We can create an example workspace. It's super fast. It's there. We can enter it. And we can do everything we want. It's its own cluster, so I would be able, for example, to say, show me the config maps. There are none, I think, so there's even one. All right, we can go back, workspace ... We are again in our demo, and I have one example here. So what we have done, we deployed a cert manager as a service, runs in its own workspace, very quickly. It has something like CRDs, but we call them API exports. Not port. Like that. Yeah, there it is. Has all the usual types which cert manager provides, and we go back to our organization. Move into a web app. It's another workspace. And here we see something called an API binding. It's like a CRD, but it's cross-workspace. So it creates CRDs in the background and binds the APIs from the other workspace, the cert manager, into here, and now we have certificates. This way you can provide APIs and semantics like controllers behind the scenes, and users can use them from catalog in the future. So API subscribing will be a thing. All right, time is nearly over. Very briefly, when you go to the repository, everything's open source, public project. Join us, watch the meetings. It's an API server behind the scenes, based on CRDs, generic, based on Kube. This is Kube, like it uses Kube code. And yeah, the red bubble here, that's what we have seen. Smallish, 1 million, up to 1 million Kubernetes clusters. That's our goal. All right, it's open. There's a Slack channel on Kube Slack. Mailing lists, the project you will find here. Everything is recorded on YouTube. There's a meeting every Tuesday. So if you're interested in rethinking the decision 7 years ago and other decisions, what can we make better but still have Kube at the end? This is KCP. Thank you.
Up next is Margot, who was not able to be here yesterday because with the flight, but will give 5 minutes of that talk today. There it goes. It's coming.
Hi everyone, my name is Margot. I'm a software engineer at VMware. This is going to be 5 minutes of a talk that I intended to be 20 minutes. So I'm going to teach you some things that I learned from being a maintainer of Pinniped about making the auth experience more seamless and easy to use. Pinniped is it's a open source authentication solution for Kubernetes. It's got lots of nice features out of the box with working with different cluster types and single sign-on. We spent a lot of time trying to make it really, really easy to configure authentication for admins and for users to use it. So I'm excited to share some of those learnings. So today I'm just going to talk to you about the cluster admin experience. So Pinniped has two different components. One of them is called the supervisor, and that defines the relationship to an upstream identity provider. So people have something in their corporate identity provider like Active Directory or Okta. There's one of them, no matter how many Kubernetes clusters you have. On the other hand, we have something called the concierge, which defines the relationship to your cluster. And there's one of those per cluster using Pinniped. So you might have one admin cluster, but you have a bunch of different workload clusters running different workloads. So why do we have a Pinniped component on every cluster? And so that, for context, I need to tell you a little more about how Pinniped works. So you log in once per day to your external identity provider. That's, again, like Active Directory or Okta or another OIDC identity provider through the supervisor. Then that gives you an OIDC JOT token, which then gets exchanged for a cluster-specific token. That's just a security hardening thing we did to ensure that even though you have single sign-on, you're not actually passing the same token to different clusters, just in case something gets compromised. You want to make sure that they're unique so they can't be replayed against other clusters. And then the last step is that cluster-specific token is turned around for an X509 MTLS client certificate on the cluster using the Pinniped concierge. So that X509 client certificate we use it because it's a method of authentication that's enabled on most clusters by default. Not going to go into it too much here. I did a whole other 30-minute talk about it at last KubeCon. If you're interested, there's a link at the bottom. But these certificates are signed by the cluster's own signing key pair, which isn't owned by anything outside the cluster, which means that we need to have this concierge on the cluster with that key pair. So we tried to make it really easy to install the concierge on every cluster. Unfortunately, networking can be pretty complicated. So requiring users to make requests to some service to give them certs requires making sure the users can access that service. And we need this, again, to be on each cluster that we're running. You could imagine this could be pretty complicated. One way that we could have made it was, you have some clusters that are running on Azure, and so they do whatever Azure-specific networking things they need to do. You might have some that are running on EKS, and some that are self-hosted, and so all of those could need to do different ways of setting up networking. But that would be really painful, and we don't want to do that. So instead, we do API aggregation. And so API aggregation allows you to add custom extensions to the Kubernetes API server. So rather than communicating with your authentication service like any regular web app, you can talk to it as if you were talking to the Kube API server, which means networking is handled by Kubernetes. So when our user makes a request to get this X509 certificate, they just talk directly to the Kube aggregator, which is part of the API server, and then it calls out to the concierge, and it routes it all back through, which is really nice for making it easier to set up, rather than this diagram, which I showed you earlier about how it could be. Everything just goes through the Kubernetes API server, which is a lot easier to deal with. Thank you for coming to my abridged version of this talk. That's all we have time for now. Thank you.
Thank you, Marga. Okay, we have the last presentation from a speaker today, and that is my colleague Rodrigo coming up here. Right after this, we'll have the closing remarks. What do you have out for you this way? You have HDMI right here too. Do you want to go directly?
Hello, I'm Rodrigo. I'm gonna talk about user namespaces support in Kubernetes. Is it big? Oh, it's not. No. Change. But is it big enough? No. Okay.
It's okay. It's just a Linux thing. Just make it a little bit bigger.
No, this is not the terminal.
You need to mirror.
Okay. Is it big now? Bigger? Yeah. Okay. Okay, so we're working on adding user namespaces support to Kubernetes. Hopefully this will be in 1.25, the next release. The idea is today when you create a container, you have a network namespace, a mount namespace, a pit namespace, but the big one missing there is the user namespace. So the idea is the user namespace allows you to abstract the user, so the users in the container are not the users in the host. So for example, root in the container can be in reality like user 10,000 in the host. And with this, there are several advantages. One is, if you escape the container, you're not root in the container. Like before, you were running as root, and there were no abstractions, so you were root in the host. Right now, with user namespaces, you are user 10,000 in this example. So, and also your capabilities are restricted. If you have some capability, you only have it in that user namespace. You don't have it in the host. So there is a very big advantage. There are in fact several CVEs that could have been completely avoided or mitigated with user namespaces. And the idea is this: like, why have a process that runs as root in the node if you don't want that process to have all the privileges? And with user namespaces, we can achieve that. So there's a CVE that was a very recent CVE a few months ago, where you can easily escape the containers. So this CVE was for Docker, but I ported it to Kubernetes. And so what I will show is what happens if we run this exploit in Kubernetes. You will get out of the container. And let's see what happens if you do it and you're running user namespaces in the pod. So this is, my cluster here locally is Kubernetes 124. And so we're going to create a pod. Nothing special, just has capsysadmin, and it will run on slip. So we're going to create this pod. Okay, let's wait until it's running. Okay, it's running, and if we say we do a PS, it's running as root. We're doing this from the host, so this is root in the host. And this is the script to exploit the CVE. So we're going to write to this file. We're going to mount as a group, do something, and write this file. That is, this is a script that will be executed, and the script will be this. The script basically will create a file on the host and leave this process running. And the file in the host will have this content. It will print the capabilities, so we see really which capabilities it has and as which user it is running. And then this is the trick to actually execute the CVE exploited. So we upload the script to the pod, and now we'll execute it. And if this worked, there should be this file in the host. It's owned by root. And yeah, the content is, you have a lot of capabilities, and you're running as UID 0, group ID 0, and yeah. And the slip process is running as root. So yeah, basically it worked, and you escaped the container. So the idea now, I'm running that in the background. The idea now is to do the same, but with a pod that is using user namespaces. So this is the field that will activate user namespaces. The idea is host network false, it uses a network namespace. With host user false, it uses a user namespace. It's exactly the same pod as before, but just with this field. So if we apply it, yeah, they should create a pod with user namespaces. Let's see. Okay, it's creating still. It should take a few seconds. Okay, it should be running. And now we see that the user is not root, is this very unprivileged user. So we're gonna upload the script, but the first line is a mount, and that line won't work. Like, we can run that line manually. Well, we can upload the script and check that that line won't work. Yeah, so it failed, but we can work around that. We can, it doesn't really matter, but we can create a nested user namespace where we can do mount, and now run the script again, and hopefully this time the script will run further. So now we can see that the mount line worked, but we couldn't write to the release agent, so our script was not copied there. So basically what happened is we couldn't register our script to run, and we couldn't write any other of the other files. But just to be super sure, let's check that the file is not there, and the sleep process isn't there either. Yeah. So what really happened is, like, the exploit didn't work because those files in the C group can only be written by root on the host, and the container is not running as root. So yeah, you cannot write it, and so you cannot exploit those kind of things. That's all. Thanks.
Thank you, Rodrigo. And with that, the content portion of this event is done, and we have a couple more minutes where we're gonna close this thing out. And we hope you had a really great time with this. This is kind of the intro to the week. I hope it was a soft intro, an enjoyable intro, something where, you know, you learned something, you got to meet those people that maybe you haven't seen in a couple years, maybe you met some new people, and especially for those people, because there are people who joined this community in the last 2 years in front of their, computer, not really getting to meet many people. And this is really the first opportunity they're having to meet people. So I hope we all, had a chance to meet those people, made them feel welcome, and I hope we get to continue to do that for the rest of the week. So before we get started, I would like to call all the people on stage who either helped organize this or were volunteers, because you folks made this happen. Come on up, come on up. Volunteers, people who... Come on, come on. I see some people back there. You, come on, come on. People who were stagehands, runners, all of them, come on up. So, this is not something that single people do. It is a team effort, and so we'd like to thank anybody. But when I say that, I'm kind of not being honest, because if there's one single person who made this all happen, it is Lexi right here. Come on, Lexi. Thank you, Lexi. Would you like to say something? Let me put you on the spot.
Yeah, no, it's okay. You do this all the time. Yeah, it's definitely not a single person effort. There definitely was a lot of help. Benazir actually just joined us April 1st. So she was kind of thrown into things, the deep end right away. She's been swimming, she's been doing amazing. I hope you guys meet her more at KubeCon. And thank you to everybody, the AV team, Teo, Maud, the whole team. You guys have made it so flawless for us. I think I'm spoiled now because in the past we actually had to do the audio visual all ourselves. Yeah, so it's been great. The venue team, you guys have been amazing. Brian over there, thank you so much. The space has been amazing. And I just hope that you guys enjoyed the first in-person event. I've had a great time, and yeah, to the next one in Detroit. Oh, we have to thank our sponsors, of course, because we keep forgetting that. Sorry. So thank you to Microsoft, Sys11, Equinix Metal, Exoscale, and Red Hat. Without you, we wouldn't be here. So yeah, thank you to everyone. And thank you to Chris, of course. Also, sorry, but you know, this is actually Chris's like baby from the get-go. He had this idea, what was it, 2019? And we had 2019 was Barcelona. But the idea, okay, anyway, he came to me with this idea and I'm like, you're crazy. But here we are in 2022 and it's, yeah, hopefully it keeps growing and you guys keep supporting us, sorry. Yeah, that's it.
Thank you, everybody. Thank you again. Yeah, Detroit is happening. We already have the dates. You have some cards in there. You know, make your flight reservations early so you can attend and tell your friends to do so too. And when you do get rejected from KubeCon, you know, we'll still be here. Thank you, everybody. Yeah, we have t-shirts. If you want extra t-shirts for the rest of your team who weren't able to come or are going to be here the rest of the week, please pick them up on the way out. Okay? Thank you.
We did it! We did it!
Coração quer cantar feliz, sorrir, dançar e viver essa vida de aprendiz.